Good evening. Tonight we will drift into the deep and distant past, to a time when the world itself seemed suspended between creation and dissolution, and the oceans, vast and unknowable, whispered the secrets of life that had yet to vanish. In the coming hours we shall wander through seas and forests long swallowed by memory, through the sweltering winds of a continent untouched by human gaze, and the silent, patient currents of time that eroded even the mightiest creatures. Subscribe if you wish, and leave a mark of your presence with a like, for these chronicles are but shadows until witnessed. Let us now descend gently into the epoch when the earth was young yet frail, and its heart beat with a rhythm both tender and terrible. The lands of the late Permian stretched wide and unbroken, a single supercontinent named Pangaea, whose edges met the restless waters of vast oceans. The coasts, jagged and irregular, were touched by tides that whispered against sandstone cliffs, carrying the briny scent of salt and the faint tang of decaying vegetation. Inland, the winds stirred dry forests and vast fern thickets, brushing against the spiny leaves of primitive conifers, their shadows shifting with the languid passage of the sun across a clouded sky. The air, heavy with warmth and humidity, bore the distant echo of life in every rustle of foliage and every crackle of bone-dry undergrowth. In the shallows, the ocean revealed a riot of colour and motion. Sheltered reefs bloomed with coral-like organisms, intricate and delicate, their structures both fragile and eternal in appearance. Crinoids, like feathered stars anchored to the sandy floor, waved with slow hypnotic grace, while mollusks scuttled beneath their shadowed spires. The water shimmered in greens and blues, the sunlight filtered through the waves to create shifting mosaics on the seafloor, where tiny predators stalked the minute crustaceans that had learned the art of evasion through millennia. Every layer of water was a stage, every ripple a passage, and every creature a fleeting testament to the abundance that defined this era. Yet beneath the surface, subtle changes began their imperceptible work. The oxygen-rich layers that had long sustained the larger animals began to thin in patches, unnoticed at first by the thriving inhabitants of the reefs. Microscopic creatures, once prolific, found the water slightly warmer, their metabolic rhythms disrupted by the faint shift in chemistry. These were not cataclysmic changes, nor did they announce themselves with violent displays. They were whispers in the currents, a slow and insidious prelude to the calamities to come. The larger fish, armoured and swift, sensed only a mild discomfort, a tugging uncertainty in the abundance that had defined their world. But the currents carried a story older than any single organism, a story written in the deep layers of water, where temperature and chemistry danced an uneasy duet. Along the coasts, the forests mirrored the ocean's subtle distress. Ancient conifers and lycophytes, dominant and unchallenged, showed signs of strain. Leaves that had once glistened with robust green now curled at the edges, scorched by the occasional heat wave or battered by sudden storms that carried ash from distant volcanic eruptions. The soil, dense and rich in mineral, held moisture poorly in the face of rising temperatures, and pockets of decay became more frequent, releasing scents of rot that mingled with the resinous fragrance of living trees. Insects, abundant and industrious, navigated these microclimates with tentative caution, their populations slightly less vigorous than in years past, their buzzing a softer accompaniment to the wind. The sky, however, remained a quiet observer, often clear but occasionally veiled by wisps of volcanic smoke from distant eruptions along Pangaea's western margins. These clouds, thin at first, spread sulphurous tendrils across the atmosphere, tinting the sunlight with pale gold and amber. The heat of the day pressed against the skin, a languid embrace that carried with it both comfort and latent menace. Shadows stretched long across the plains, and the evening brought a humid hush, punctuated only by the faint croaks of amphibians near the shrinking ponds and the occasional cry of a distant predator, its voice absorbed into the humid air before reaching the ocean. In these quiet hours the reefs below continued their eternal motion. Sea stars crawled across sediment, oblivious to the shifting chemistry, while the larger mollusks grazed on algae that still flourished in shaded nooks. Schools of primitive fish swept in unison, their scales reflecting the fractured sunlight, a living mosaic of silver and jade. Even at this nascent stage of disruption, life retained its grace. a delicate balance that seemed destined to endure. Yet every flicker of fin and flutter of frond carried within it a fragility that only time could expose. The inland landscapes bore witness to the subtle interplay of life and decay. Ferns and seed ferns grew in dense thickets along ephemeral streams, their roots entwined with ancient soil. Tiny arthropods burrowed beneath leaf litter, feeding and reproducing in cycles older than memory. Larger reptiles roamed cautiously, their movements deliberate, each footfall measured against the soft earth. It was a world that seemed to breathe in unison, where each living thing played its part in the grand, unspoken symphony of existence. Yet beneath this rhythm, the first notes of discord had begun to sound. A slight increase in soil salinity here, a sudden die-off of microorganisms there, imperceptible shifts that presaged the coming unrest. The coastal wetlands were a theatre of contrasts. Mangrove-like plants clung to brackish waters, their roots arching like fingers into the shallow pools. Small amphibians leapt between roots, their skins slick and glistening, while the occasional predatory fish darted beneath the surface. The water itself was warm and fragrant with life, yet pockets of stagnation began to form where tidal flows slowed. Within these stagnant pockets, the water grew turbid, a soft green haze that hinted at unseen chemical shifts. The creatures within them seemed slightly slower, their movements measured, as if sensing the subtle burden of change pressing upon them. As the sun climbed higher, the wind carried the scent of distant fires and the faint tang of sulphur. Across the plains, dust rose in gentle swirls, catching the light in shimmering columns. Insects and small reptiles took shelter beneath the canopies, and larger animals, herbivorous tetrapods, moved cautiously, eyes alert to both predator and environment. There was a sense of expectancy in the air, though no creature could name its source. The earth itself seemed to hold its breath, the rhythms of life continuing while a slow, inexorable shift began to alter the foundations of existence. Underneath it all, the oceans were changing. Thermal gradients began to fluctuate, and layers of water that had remained stable for eons now mixed unevenly. Nutrient flows altered subtly, affecting plankton and the myriad microorganisms upon which the larger creatures depended. Reef structures, intricate and delicate, began to show faint signs of stress. Coral-like organisms with bleached tips, crinoids moving more slowly, and mollusks that lingered longer in sheltered crevices. It was a quiet disturbance, yet it spoke of a future where abundance would no longer be guaranteed, where life would be tested against conditions never before encountered. Even as the reefs faced their early trials, the larger predators of the ocean's primitive sharks and lobe-finned fish continued their hunts. Their movements were precise, almost ritualistic, as they navigated the labyrinthine structures of the reef. Each strike, each pursuit was executed with a grace that belied the underlying tension in the environment. These creatures were the apex of their ecosystems, yet they were not immune to the subtle shifts in temperature and oxygen that would, in centuries hence, dictate the survival of all marine life. Beneath their scales and gills, the quiet unfolding of catastrophe had already begun, though the world above remained unaware. The forests inland responded in kind, though differently. Heat waves from the tropics pressed into the interiors, desiccating ferns and low shrubs. The resinous smell of conifers mingled with the faintly acrid scent of burning underbrush from distant volcanic activity. Animal populations adjusted their routines, some migrating toward dwindling water sources, others retreating into shadowed hollows. Each generation experienced the shift in subtle ways, learning patterns of scarcity even as the larger environment seemed unchanged. The tapestry of life remained intact, yet its threads were becoming taut, the possibility of rupture ever closer. Along the rocky coasts, tidal pools glimmered under the pale sunlight, microcosms of life that reflected the larger struggles at hand. Small mollusks clung to stone, their shells glinting, while crustaceans darted beneath the water, avoiding the subtle predators that prowled above. Seaweeds swayed with the rhythm of the tides, their pigments slightly faded, signaling the slow encroachment of stress. In these intimate ecosystems, every organism was acutely aware of change, its survival dependent on the careful calibration of behavior to the evolving environment. Even the smallest fluctuation in temperature or salinity could cascade into consequences far greater than its size might suggest. Beneath the surface of deeper waters, the story of life unfolded with the quiet insistence of geological time. Layers of plankton drifted like drifting snow, feeding small fish and invertebrates that navigated the dim, filtered light. Shadows moved in the currents, shapes ancient and precise, creatures that had survived countless cycles of growth and extinction. The warmth of the water carried both comfort and menace. It accelerated metabolism and subtly altered the chemical balance, unseen by the eyes of those who lived within it. Oxygen pockets shifted imperceptibly, creating zones where survival demanded adaptation, where only the flexible and resilient could persist. Above, the atmosphere responded to distant volcanic activity. Ash and sulfur traces began to tint the air with a faint orange haze at dawn, softening the light and lending a golden pallor to landscapes that had once glistened in full daylight. Winds carried the scent of burnt forests and mineral-rich soil. Mingled with the humid perfume of ferns and flowering seed plants, the day stretched languidly, heat pooling in shallow valleys, while the sky's dome retained a clarity punctuated by the occasional wisp of smoke. In these conditions, the movements of terrestrial creatures slowed, their behaviours subtly adjusted to the pressures of a shifting environment, unaware that these were the first signs of a slow unravelling. The insects were the first silent witnesses to change. Populations that had once been immense thinned in patches, their buzzing diminished in volume and frequency. Beetles and early orthopterans wandered with less certainty, their search for sustenance complicated by subtle changes in leaf chemistry and moisture. Predatory insects dependent upon these smaller forms followed a cascade that began in the soil and ascended through canopies to the highest branches. Everywhere life continued, yet in the background there was a quiet, growing strain, a tension that would, in time, become the overt turmoil of collapse. The inland waters, lakes, swamps, and ephemeral ponds displayed a similar story. Algal blooms appeared earlier than expected, tinted green by excess nutrients carried from eroded soil. Frogs and temnospondyls, amphibians of varying sizes, adjusted their breeding cycles in response, some laying eggs sooner, others retreating from pools that began to warm beyond comfort. Crustaceans and mollusks inhabiting these freshwater environments faced a more immediate peril. Oxygen saturation decreased with rising temperature, and predation dynamics shifted as hunters adapted to changing prey distributions. Even minor shifts, unnoticed by the majority of species, became significant in their cumulative effects. On the coasts, tidal flats were dotted with pools reflecting the reddened skies. Small creatures, crabs and early bivalves, clustered in refuges where water remained cool and oxygenated, while others succumbed quietly, swept into detritus, or covered by the shifting sands of the tidal flow. Algae turned faintly brown where sulfur-rich runoff reached them, a subtle indication of the chemical perturbations spreading from distant volcanic centres. The world in these intimate spaces mirrored the broader, slow decay, an intricate network of life and environment responding to a slow, inexorable transformation. Further offshore, the great reefs, once dense and unassailable, began to manifest fragility. Coral-like structures, layered and intricate, showed signs of bleaching. Crinoid forests, though still waving in the currents, thinned as their food sources became less reliable. Small predatory fish adjusted their hunting patterns, moving between crevices and hiding spots in new, uncertain ways. The quietude of these environments carried a latent tension, a persistent whisper of instability beneath the surface beauty. Even without storms or tides, the oceans were subtly reshaping the prospects for survival in ways that only centuries would fully reveal. The inland forests displayed similar echoes. Trees, deeply rooted and resilient, nevertheless began to exhibit minor stress indicators, discoloured foliage, shortened growth, and irregular reproductive cycles. Seed ferns and conifers alike shed leaves early, not from seasonal dictates, but from subtle physiological responses to shifts in soil and climate. Herbivorous reptiles noticed the thinning undergrowth, moving with more caution and conserving energy as they sought sustenance in ever-depleting resources. Carnivores, in turn, adjusted their patrols and hunting times. The entire ecosystem engaged in a silent recalibration of survival strategies. As days passed into weeks, the first pronounced anomalies emerged. A heat wave swept across the western plains of Pangaea, causing ephemeral pools to evaporate entirely, leaving cracked basins of clay and mineral. Insects perished in their millions, scattered across the drying ground, and the small amphibians that depended on the pools retreated or succumbed. Birds did not yet exist in these times, but the creatures of the land, small reptiles, early synapsids, wandered the scorched soils in search of shelter. It was a gentle but undeniable sign that equilibrium was fragile, and the planet itself was beginning to whisper warnings that few could heed. Above, the atmosphere thickened slightly with distant volcanic dust. Hazy streaks painted the sky with shades of ochre and muted amber, softening shadows yet imparting an unsettling stillness. Winds, once brisk and refreshing, became sluggish, carrying with them the faint scent of sulphur and scorched vegetation. The heat pressed heavier, a slow weight upon every living creature, while the light itself seemed diluted, filtered through layers of particles suspended high above the surface. Nature's pulse slowed, and yet all life continued, its rhythm adjusted in subtle, almost imperceptible increments. The coastal lagoons became laboratories of change. Water temperature varied from shallow edges to deeper pools, and microalgae responded first to these shifts, altering coloration and density. Tiny crustaceans and mollusks adapted by migrating within these zones, sometimes perishing in shallow areas exposed to sun. Predatory fish followed cautiously, their instincts finely tuned to the altered distribution of prey. Each small movement, each subtle behavioral adjustment, was a response to the new pressures, a precursor to larger, more dramatic changes yet to come. Inland, the forests remained thick with vegetation, yet a certain stillness began to pervade. Insects buzzed less vigorously, the undergrowth rustled less frequently, and the larger herbivores were increasingly solitary, conserving strength against the gradual scarcity of nutrition. Occasional storms swept across the plains, but these were not violent. Rather, they carried ash and fine particulate from distant eruptions, leaving behind a thin film on leaves and rocks, subtle yet persistent. Even the light rain carried traces of mineral and chemical shifts, altering the soil chemistry in imperceptible ways that would, over decades, compound into larger ecological disturbances. The seas in particular told a story only discernible over time. Oxygen-rich surface layers gave way to zones of mild depletion, creating pockets where survival became more difficult for gill-breathing organisms. Fish adjusted their schooling patterns, moving in tighter formations or seeking cooler currents. Mollusks clung to rock surfaces with greater tenacity, and sessile organisms exhibited slower growth. The interplay between temperature, salinity, and oxygen availability was subtle, but increasingly decisive, a silent orchestration that foreshadowed mass disruption. Along the shores, the larger reptiles roamed with caution. Herbivorous species sought out the last remaining patches of moisture and shade, their movements deliberate, measured. Small predators followed their prey closely, adjusting hunting strategies to the new distribution of resources. Everywhere, life adhered to its age-old rhythms, yet those rhythms were stretching, bending under the slow weight of environmental change. The earth, in its vastness, held a mirror to the resilience and fragility of life, offering a stage where each creature played its part, unaware that the curtain would fall sooner than any could imagine. The sun, descending toward the western horizon, cast long shadows that lengthened across plains, forests, and coastal wetlands alike. Light filtered through the hazy air, softening outlines and blending colours into muted golden tones. Insects gathered at water edges. Reptiles sought refuge in the cooling soil or among rocks. Fish shifted within the reefs towards slightly cooler currents. Every organism responded in its own way, yet all were participants in the same quiet drama, a story unfolding without haste, without spectacle, but with inexorable purpose. The evening brought with it a heavier hush. The wind, now barely perceptible, carried with it the faint metallic scent of distant volcanic dust and the lingering aroma of decaying vegetation. Pools and lakes reflected a sky tinged with ochre, the reflection slightly disturbed by the occasional ripple of a fish or the slow movement of a small amphibian. The forests grew still, the undergrowth ceased its faint rustle. A single, almost imperceptible tremor of tension threaded through every living system, binding the ocean, the land, and the air in a subtle, unbroken chain of consequence. Nightfall did not bring cool relief. The air retained warmth, the heat of the day stored in soil and water. Sounds of nocturnal creatures were muted. The world seemed to breathe collectively, a slow, deliberate inhalation and exhalation of life, yet beneath the surface currents and within the soil, chemical and thermal shifts continued. The oceans, pools and wetlands held the first whispered signs of the great transformations to come, while the land with its forests and plains adjusted silently, imperceptibly to the growing pressures of heat, dryness and chemical imbalance. Even in the depth of night the ocean's surface shimmered faintly, reflecting the amber sky, while deep below life persisted with delicate care. Crinoids waved in slow rhythm, mollusks grazed on the dimly lit surfaces, and small predatory fish darted between crevices, unaware of the slow collapse encoded in their habitat. Inland, the last murmurs of nocturnal activity carried through the forests, the scuttling of insects, the faint drip of moisture, the cautious movement of reptiles seeking temporary shelter. The world remained alive, yet it had already begun the slow and inexorable descent into the conditions that would, over millennia, shape the greatest extinction the Earth would ever witness. And so, as the first night of subtle change passed, the planet held its breath. Life, abundant and intricate, endured in its familiar patterns, yet beneath the harmony lay the seeds of fragility. In the quiet stirrings of the oceans, in the stillness of forests, and in the warmth that clung to land and water alike, the earliest murmurs of upheaval whispered through every layer of existence. This was the opening scene of a tale that would stretch across centuries, a tale of resilience and collapse, of abundance and loss, of an Earth caught between persistence and inevitable transformation. The dawn that followed the long, muted night of change brought with it subtle disturbances across land and sea, disturbances that whispered through the ecosystems with a quiet insistence. The sky, tinged with pale gold and streaked with distant clouds of volcanic ash, cast light that seemed softer than before, as if filtered through some invisible veil. Across Pangaea, the coasts shimmered in the early light, revealing the gentle lapping of waves against shores both sandy and jagged. In these shallow waters, the first discernible signs of imbalance were already apparent. Algae bloomed in muted patches, colouring the water with faint green streaks, while mollusks lingered near sheltering rocks longer than their usual routines dictated. Small predators, once swift and assured in their hunting, paused, perhaps sensing the altered rhythms beneath the surface, as though the currents themselves were warning of forthcoming disruption. In the deeper zones of the reefs, the water retained a crystalline clarity, yet the creatures that inhabited it were slowly adjusting. Crinoids waved with slightly less vigour, their feathered arms folding and stretching in irregular cycles. Tiny fish, dependent on oxygen-rich layers near the surface, began migrating to cooler, slightly more distant waters. The reef's intricate architecture, once a constant in the lives of its inhabitants, now appeared less stable, every spire and ridge subtly altered by temperature shifts that only time could reveal. Even here, life continued, graceful and precise, yet beneath its rhythm, the first tremors of an ecological imbalance rippled unseen, heralding transformations that would not yet be named. On land, the forest displayed a similarly quiet unrest. The conifers and seed ferns, long, resilient against the shifting winds and sun, showed irregular growth patterns. Leaves curled at edges and stems bent slightly under the subtle pressure of chemical changes in the soil. Herbivorous reptiles, sensing variations in plant nutrition, adjusted their feeding paths, often venturing farther or lingering longer in areas once deemed too sparse. Predators in turn noted these shifts, following their prey with increased caution, learning the silent cues of a changing environment. The web of life persisted, but the threads of its tapestry were subtly fraying. Volcanic activity, though distant, began to assert a gentle but noticeable influence. Faint plumes of smoke and ash drifted over the western margins of Pangaea, tinting sunlight with hues of amber and rose. The smell of sulphur, almost imperceptible at first, mingled with the earthy fragrance of moist soil and resinous forests. Winds carried these scents inland, touching distant wetlands and lakes, depositing fine particles upon still waters and plant surfaces. Each flake of ash was minor, yet cumulatively, they began to alter chemical balances in soils and water, creating micro-environments where only adaptable species could thrive. The tidal flats and coastal lagoons reflected these subtle shifts in the lives of their inhabitants. Small crabs scuttled over sediment more cautiously, and bivalves, their shells glinting faintly, remained partially buried longer than usual. The greenish hues of algae fluctuated, thickening in shaded nooks and thinning in sunlit areas, altering the diet and behaviour of grazers. Predatory fish, attuned to these nuanced changes, modified hunting times and patterns, a dance of survival guided by imperceptible environmental signals. Even in these microcosms, the slow, deliberate push toward imbalance was beginning to manifest. Freshwater environments, rivers, lakes, and shallow ponds exhibited the earlier stages of chemical disruption. Algal blooms became uneven, oxygen levels varied sharply between shaded depths and sunlit shallows. Small amphibians, once numerous and confident, displayed hesitation, retreating to cooler or more protected waters. Crustaceans moved with increased care, avoiding shallow zones that might now turn inhospitable for hours at a time. Every organism, from the tiniest plankton to the larger amphibians, adjusted its behaviour imperceptibly, a subtle choreography responding to forces they could neither name nor perceive, guided only by instinct and necessity. Insects, delicate yet crucial components of terrestrial ecosystems, were among the first to register the shifts. Beetles, early orthopterans and other arthropods displayed minor behavioural changes, their movements less vigorous, their reproductive cycles subtly altered. Even the abundant detritivoraes, which sustained much of the soil's nutrient flow, became less frequent in certain regions, their absence barely perceptible yet pivotal. Predatory insects followed the changes of their prey, the cascading effects quiet and slow yet cumulatively significant. Across forests and plains the air buzzed slightly less. The once constant background of wings and legs in motion softened in tone and intensity. The shallow coastal waters provided a mirror to the broader disruptions. Pools trapped by receding tides began to warm faster under sunlight, creating localized stress for the organisms within. Mollusks and small crustaceans moved to cooler microhabitats, often leaving exposed areas vacant. Predators, instinctively adjusting, moved more deliberately, their hunting behaviours modulating to the new distribution of prey. Even subtle alterations in water temperature and chemical composition began affecting reproduction cycles, with eggs hatching earlier or later than optimal, subtly shifting population dynamics. The reef's once predictable patterns now carried the first hints of unpredictability, the earliest marks of imbalance that would widen in time. Offshore, deeper waters showed initial signs of thermal stress. Layers once stratified for oxygen content and temperature began to fluctuate. Fish that had once migrated in precise schools adjusted formations, seeking optimal conditions. Mollusks lingered in their shelters, feeding less aggressively, while sessile organisms extended or contracted growth periods in subtle response to environmental cues. The reef, though still a sanctuary of abundance, exhibited its first visible cracks in resilience, though these were invisible to the casual observer. Beneath the apparent calm, the ocean carried the whispers of change, a prelude to the more profound upheaval awaiting in centuries to come. Inland, the forests experienced analogous pressures. Seed ferns, tall and spiny-leaved, displayed patches of early leaf drop, likely induced by minute shifts in moisture and nutrient balance. Conifers, long dominant, developed sporadic areas of discoloration and slowed growth. Herbivorous reptiles adjusted feeding strategies in response, foraging over wider areas and conserving energy in ways that were subtle yet adaptive. Predators tracked these movements with increasing caution, subtly adjusting their territories and patrols. The forest remained alive, dense and vibrant, yet a quiet tension pervaded, a sense that the rhythm of life was under gentle but inexorable strain. Volcanic emissions, although minor at this stage, influenced ecosystems even at a distance. Dust carried in high currents settled in shallow ponds, coating leaves with fine grey powder. Rain, infused with trace sulphur, deposited slight acidity upon soils and plant surfaces. While the immediate impact on larger animals was negligible, for smaller creatures and microorganisms, the chemical shifts were palpable. Algal growth patterns in freshwater habitats fluctuated more rapidly, invertebrate populations shifted microhabitats, and soil-dwelling organisms adjusted their burrowing behaviours. Each minor change compounded others in ways that only time could reveal. Even in the deep ocean, thermal and chemical gradients began to shift imperceptibly. Stratified layers of nutrient and oxygen altered slowly, creating microenvironments of marginal viability. Predatory fish and cephalopod-like creatures adapted by changing hunting patterns, lingering longer in cooler currents or retreating to shaded crevices. Crinoids waved less rhythmically, and the tiniest plankton exhibited altered reproductive timing. These small responses, invisible to human eyes and imperceptible to the larger animals that depended upon them, were early threads of disruption in a tapestry that had endured for millions of years. On land, small-scale disturbances mirrored those of the seas. Ephemeral ponds evaporated earlier in the heat of the day, concentrating salts and trace minerals, forcing amphibians and invertebrates to move or perish. Forest undergrowth displayed irregular growth patterns, leaf litter decayed unevenly, subtly altering nutrient cycles. The faint buzzing of insects diminished further, while larger herbivores became increasingly solitary, conserving energy in a landscape subtly shifting beneath their feet. Each organism moved, fed, and reproduced according to instinct, unaware of the larger transformation threading through its world. By midday, the air carried the scent of warmth and ash, faint yet persistent. Sunlight, filtered through distant volcanic haze, fell upon forests and plains with softened intensity, casting long, gentle shadows that stretched across undulating terrain. Inland, herbivorous reptiles lingered near shaded areas, sometimes near ephemeral water sources, moving slowly to avoid exhaustion. Predators adjusted hunting patterns accordingly, subtly, in accordance with environmental cues. The web of life remained intact, yet the first delicate fissures had begun, unremarkable in isolation but collectively significant. The tidal flats and lagoons along the coasts provided early indications of larger shifts. Shallow pools, warmed by the sun and shaded in part by algae blooms, forced crustaceans and mollusks to migrate, leaving some areas temporarily barren. Predatory fish and small hunters observed, adjusting their patterns in response. Even minor variations in water temperature and salinity induced subtle changes in reproduction cycles and foraging behavior, which, over months, compounded into larger system-wide shifts. The calm and routine of life, previously unwavering, now contained the first murmurs of adaptation to environmental stress. Across the landscape, the forests whispered similar stories. Seed ferns and conifers, accustomed to cycles of sun and rain, reacted subtly to shifts in moisture, temperature, and soil chemistry. Leaf discoloration, early shedding, and slight reductions in growth were imperceptible to larger animals, yet these minor stresses altered the feeding patterns of herbivores. Predators adjusted accordingly, the rhythms of predation and avoidance recalibrated. The forest's intricate web of interactions endured, yet the strains that now appeared would grow steadily, imperceptible, yet inexorable. Even as evening fell, the subtle transformations continued. Shallow waters reflected amber skies, and small organisms adjusted their microhabitats in preparation for night. Insects, amphibians, and reptiles moderated activity to conserve energy. Their instinctive responses, guided by environmental cues, altered subtly yet consistently. The ocean's surface shimmered faintly in reflection of the muted light, while deeper currents carried temperature shifts that would, in time, influence reproductive cycles and migratory behavior. Across land and sea, life endured, yet it was beginning to navigate an environment increasingly defined by instability. Night descended with the quiet persistence of inevitability. Winds slowed, carrying with them traces of ash, sulfur, and dust. Forests became still, pools and shallow lagoons reflected a darkened sky, and the ocean's surface mirrored the faint orange glow of distant atmospheric disturbances. All life held to familiar routines, yet the rhythm had altered slightly. Metabolic cycles, feeding behavior, and movement patterns adjusted subtly to the first whispers of a world no longer entirely hospitable. The first true echoes of imbalance had entered the living world, unseen but felt in every breath, every movement, every flicker of gill and wing. And so, the early signs of disruption in oceans, forests, and wetlands marked the beginning of a story that would unfold over centuries. Though subtle, these initial disturbances, minor shifts in temperature, oxygen, and chemical composition, were the prelude to events of much greater consequence. the opening movements in a symphony of extinction that would engulf the Earth. Life, resilient yet delicate, continued in patterns evolved over millions of years, yet the stage had been set for the first irreversible departures from abundance and harmony. The distant horizon of Pangaea trembled faintly, though not in the manner of earthquakes or tidal surges. Rather, it quivered with the quiet insistence of forces that had slept for eons, forces that now, imperceptibly at first, began to awaken. Along the western margins of the supercontinent, the ground held the secret tremors of magma rising from deep within the crust, feeding fissures that would soon erupt with relentless fury. From these nascent volcanic centers, smoke and particulate matter began to seep skyward, carrying with it sulfur, ash, and gases unfamiliar in concentration to the life forms that had so long thrived under more forgiving skies. The sun, filtering through this subtle haze, cast a pallid, almost sickly light across the plains and forests, softening shadows yet adding an almost spectral quality to the landscape. In these early stages the change was not sudden. It was a patient, persistent pressure, like the slow tightening of a hand around the breath of the living world. Beneath the oceans, the effect of this activity manifested in subtle shifts of temperature and chemistry. Surface layers warmed slightly, and thermal currents began to fluctuate in ways previously unknown. Oxygen, once plentiful, diminished in patches, creating small zones of stress for fish and invertebrates alike. Coral-like structures, intricate and fragile, exhibited signs of early bleaching, their spires paling against the deep greens and blues of the surrounding water. Crinoids, swaying gently with the currents, moved with less fluidity, as if sensing a disturbance that they could not comprehend. Tiny plankton, sensitive to both temperature and nutrient shifts, altered their reproductive cycles, sending ripples of consequence up the food chain. The seas, though outwardly calm, were already carrying the early signatures of upheaval. On land, the forests and plains responded differently but no less dramatically. Conifers and seed ferns displayed scattered dieback, small patches where leaves browned and fell prematurely, while stems and trunks showed subtle signs of stress. Herbivorous reptiles adjusted their feeding routes, moving more cautiously across the terrain, seeking out pockets of viable plant life. Predators observed these patterns, recalibrating hunting strategies to match the altered behavior of their prey. Even in the absence of dramatic events, the ecological balance began to strain. Each small adjustment, each imperceptible adaptation, was part of a broader pattern that no single species could discern, yet all were compelled to follow. The volcanic plumes rose steadily, spreading sulfur and fine ash across hundreds of kilometers. The scent, faint but insistent, settled into wetlands and river valleys, subtly altering water chemistry. Pools that had previously been clear now carried a tinge of yellow or green, and the amphibians that inhabited them began to exhibit changes in behavior, hesitancy, altered breeding cycles, and subtle avoidance of previously frequented areas. Small invertebrates, their life cycles tightly coupled with environmental cues, found some microhabitats less hospitable than before, migrating in patterns that shifted incrementally with the changing chemistry. Across the landscape, life adjusted, unaware that these minor inconveniences were but the first whispers of a catastrophe, still distant in perception, but close in inevitability. The air itself began to thicken with particulate matter. Distant eruptions released plumes that, though dispersed by wind, lent a faint amber hue to daylight. Shadows fell differently across the plains and forests, and the light of dawn took on a muted, almost mournful quality. Wind currents carried the trace odours of sulphur and charred vegetation, mingling with the familiar scents of soil and resin. These subtle olfactory shifts were imperceptible to the larger animals beyond instinctive avoidance, yet they indicated profound chemical changes in the environment. Even slight increases in acidity and rainfall began to affect foliage, weakening leaves and subtly altering growth patterns across vast stretches of land. The oceans, vast and patient, responded to this atmospheric and geologic pressure in ways both slow and transformative. Thermal stratification altered as currents carried heat and minerals to new depths. Oxygen levels fluctuated, creating temporary hypoxic zones that forced marine life to migrate or endure periods of stress. Mollusks retreated to shaded crevices, fish schools adjusted migration routes, and sessile organisms altered feeding and growth cycles. Though these changes were minute in isolation, they formed the beginnings of a cascade, shifts in the base of the food chain that would reverberate upwards, touching every layer of marine existence. Even the reefs, which had persisted for millions of years, began to show their vulnerability to the slow, inexorable transformation of their environment. Coastal wetlands displayed analogous disturbances. Mangrove-like plants and fern thickets were subjected to slightly elevated temperatures and trace acidity in tidal waters. Small amphibians and crustaceans adjusted by seeking cooler, less saline pockets, while predators followed cautiously, responding to the altered distributions of their prey. Algae in tidal pools experienced localized blooms or die-offs, further affecting food availability. Each species reacted to subtle environmental cues, though none yet understood the scale of the forthcoming changes. The landscape remained visually unchanged, lush and vibrant to the eye, yet each organism felt the quiet tug of imbalance pressing upon its existence. Inland waters, lakes, rivers, and ephemeral ponds reacted similarly to distant volcanic activity. Algal density increased unevenly, oxygen levels fluctuated, and nutrient distribution shifted. Amphibians exhibited hesitation, migrating across the margins of shrinking pools or retreating to shaded depths. Invertebrate populations moved accordingly, often concentrating in less ideal habitats, risking predation or desiccation. Even small changes in water chemistry influenced reproductive cycles, subtly altering population dynamics over days and weeks. Each microcosm, though small, reflected the larger planetary shifts, like a mirror of subtle imbalance magnified in scale and consequence. Insects, too, reflected the first behavioral responses to environmental stress. Their movements became more cautious, their reproductive timing adjusted in response to subtle cues in humidity and vegetation quality. Detritivores, integral to nutrient cycling, shifted activity patterns, influencing soil quality and indirectly affecting plant growth. Predatory insects followed these changes, creating a chain reaction across trophic levels. The forests, once a vibrant hum of motion, became slightly quieter, a gentle diminution of sound signaling early biological response to unseen forces. Life, in all its forms, began to operate under new unspoken constraints. Along shallow reefs, early signs of disruption were manifest. Coral-like structures exhibited paler coloration at tips and edges, crinoids waved with less vigour, and small predatory fish adjusted hunting routines. Subtle shifts in plankton distribution influenced the feeding patterns of mollusks and microfauna. Predators, both small and large, responded to these minor yet consequential changes, demonstrating the first indications of cascading ecological effects. The ocean, though outwardly serene, carried within its currents the hidden pulse of disruption, a silent orchestration of imbalance that would grow increasingly pronounced over time. Forests inland mirrored these processes. Seed ferns, tall and broad-leafed, displayed sporadic early leaf drop, indicating stress from slight soil acidity and temperature changes. Conifers showed signs of slowed growth, minor discoloration, and irregular reproduction cycles. Herbivorous reptiles adjusted feeding behavior, wandering longer distances or conserving energy in response to altered plant quality. Predators tracked these patterns subtly, altering territorial range and hunting behavior in response. The balance of life persisted but had become delicate, teetering beneath the weight of slow, unseen pressures. As weeks passed, the intermittent tremors of volcanic activity strengthened. Plumes of smoke and particulate rose steadily, tinting the sky and infusing wind currents with sulphurous compounds. Ash settled across soils and foliage, altering nutrient content and subtly affecting water chemistry in nearby ponds and streams. Amphibians and insects responded to these changes, altering habitat use, reproductive timing, and foraging behavior. Each organism's adaptation was small and individual, yet cumulatively these shifts reshaped local ecological networks, foreshadowing larger-scale consequences that would extend across continents. The oceans continued to respond in quiet yet profound ways. Stratification shifted, creating zones of variable temperature and oxygen availability. Fish and mollusks adapted by seeking cooler, more stable layers, while sessile organisms extended or delayed growth, according to subtle environmental cues. Coral-like reefs displayed irregular patterns of bleaching, while plankton populations oscillated in response to changes in nutrient availability. Every adjustment in feeding, growth, and reproduction, though imperceptible to larger creatures, contributed to a slow, inexorable shift in ecosystem dynamics, the first murmurs of a planetary-scale transformation. Even inland forests reflected these silent changes. Soil composition shifted gradually as ash and mineral deposits mixed with rainfall, altering nutrient availability. Plant growth was irregular, leaf coloration varied, and detrital cycles slowed. Herbivorous reptiles moved with greater caution, conserving energy, while predators adapted subtly to prey availability. Insects displayed modified activity patterns, leading to minor yet significant changes in pollination and soil turnover. The interconnections of the forest ecosystem, once stable and predictable, began to flex and strain under pressures still barely perceptible to life itself. By midday, the subtle disturbances of volcanic activity, temperature shifts, and chemical alterations had propagated through the seas and land alike. Sunlight, muted by ash-laden air, cast soft amber tones across plains, forests, and coasts. Shallow pools reflected this light with altered colour, signalling changes in chemical and thermal balance. Amphibians, insects, and reptiles moved in response, adjusting behaviours according to instinctive recognition of environmental cues. Fish and invertebrates in near-shore waters shifted positions, feeding rhythms adjusted, and reefs displayed nascent signs of bleaching. Life persisted, yet it was increasingly orchestrated by conditions no creature could name or anticipate. As evening fell, winds slackened, carrying with them lingering traces of sulphur and ash. Forests and plains quieted. Amphibians and insects settled in sheltered areas. Water surfaces mirrored the reddened sky, and the first true signs of hypoxia appeared in isolated ocean pockets. Though subtle, these zones were early indicators of a broader trend, the preliminary stages of an imbalance that would soon accelerate. Life, adapting in myriad small ways, unwittingly set the stage for the more dramatic upheavals that would define the epoch to come. Night brought heat retained in soil and water, a lingering warmth that amplified chemical reactions in both terrestrial and aquatic habitats. The forests and plains, though still vibrant, operated under altered rhythms. Amphibians lingered in pools, fish shifted layers within the reef, insects moderated activity. The stage was set for a slow yet inexorable transition, a world in which the first true casualties of environmental upheaval would soon emerge. Life endured, but its resilience was being tested by forces still invisible, subtle yet insistent, whispering the inevitability of change. The oceans of Pangaea had begun to betray their once constant rhythm, their vast expanse showing signs of an unrest that had been centuries in the making. Beneath the surface, layers of water that had once provided stable refuge for myriad life forms now wavered in temperature and composition, creating zones of lethargy and tension. Currents that had for millions of years circulated warmth and nutrients with predictable precision became irregular, sluggish in some places, turbulent in others. The upper layers, warmed by both sun and the distant touch of volcanic heat, carried less oxygen than they had before, while deeper waters, long stable and cold, received unexpected warmth, altering chemical stratification. These subtle changes, imperceptible to casual observation, were the opening movements of a catastrophic symphony in which life would soon struggle to find its footing. Shallow seas near the western margins reflected the amber haze of a sky tinged with ash. Coral-like organisms, delicate in structure, began to bleach at their edges, their vibrant colours fading to muted pale tones. Crinoids, once rhythmic and graceful in their waving, slowed, their movements erratic and less coordinated. Mollusks clung to rocks and reef surfaces with a tenacity born of necessity, conserving energy as the surrounding waters shifted in warmth and oxygen content. Schools of small fish, instinctively attuned to these subtle signals, altered their schooling patterns, moving in tighter formations, yet even this adaptation could not fully counter the increasing instability of their environment. The balance that had persisted for eons was faltering under the gentle but relentless pressures of thermal and chemical change. In deeper waters, the effects were equally pronounced. Plankton, the microscopic base of the oceanic food chain, responded first to the changing thermal gradients, their reproduction cycles altered and their populations fluctuating unpredictably. Invertebrates, dependent on these planktonic blooms, found the availability of nourishment inconsistent, leading to slower growth and reduced reproduction. Predatory creatures, both small and large, shifted hunting grounds, yet even with these behavioral adaptations, mortality began to rise incrementally. The web of life beneath the waves was fraying in subtle but inexorable ways, each thread a measure of resilience under stress, now being tested beyond prior limits. Along coastal shelves, tidal pools displayed the first overt signs of anoxia. Oxygen-depleted pockets expanded, suffocating mollusks and crustaceans that had once flourished in shallow sunlit waters. Fish, sensitive to oxygen content, migrated erratically, some leaving the pools entirely, others clinging to deeper or more aerated zones. Algae, previously vibrant and consistent in growth, fluctuated erratically, with blooms concentrated in areas where competition had been reduced by the death of other organisms. Predators adjusted, yet even their instincts were insufficient to fully mitigate the rapidly shifting availability of prey. The interconnectedness of marine ecosystems, once their strength, now revealed a fragility that had been dormant, latent, and now awakened. Further offshore, deeper waters reflected subtle yet dramatic changes. Thermal currents carried unexpected heat into previously stable layers, and the resulting disruption in density stratification altered nutrient flows. Sessile organisms, those that had depended on predictable plankton cycles, found survival increasingly difficult. Crinoids moved sluggishly, their feathered arms folding and unfolding with delayed precision. Mollusks showed reduced feeding activity, and the delicate balance between predator and prey began to tilt, with some species declining even as others temporarily flourished. Life continued, but the rhythm was broken, replaced by an unsteady pulse that foretold the cascading losses yet to come. On land, the coastal forests and plains mirrored the distress of the seas, though the manifestations were different. Seed ferns and conifers displayed patchy dieback, leaves yellowed or browned prematurely, and some trees dropped foliage irregularly, signalling stress from subtle changes in moisture and soil chemistry. Herbivorous reptiles adjusted feeding paths, wandering longer distances and conserving energy where resources became scarce. Predators, in turn, monitored these shifts, calibrating patrols and hunting behaviors in response. The interdependence of terrestrial ecosystems began to strain under combined pressures of temperature, chemical shifts, and changing water availability, a mirror of the stresses unfolding beneath the waves. Volcanic plumes continued to extend across the skies, their particulate matter settling over land and sea alike. Ash-coated soils altered nutrient content subtly, while rainfall infused with trace sulfur shifted the chemical balance of freshwater systems. Amphibians retreated to deeper, more stable pools, insects sought cooler microhabitats, and reptiles altered activity cycles to conserve energy and minimize exposure to the increasingly harsh atmosphere. The cumulative effect of these subtle alterations began to affect species interactions in ways invisible to any single observer, yet decisive in the unfolding trajectory of ecosystems across the supercontinent. The open ocean experienced similar pressures, though less immediately visible. Thermal anomalies reached deeper layers, altering oxygen availability and nutrient distributions. Plankton responded by shifting their vertical movements, affecting the availability of food for invertebrates and small fish. Sessile organisms dependent on regular nutrient flux showed slower growth and decreased reproductive output. Larger predators, hunting over extended ranges, experienced inconsistent prey density, adjusting behavior yet suffering incremental losses. The once unbroken productivity of these waters was beginning to waver, the first signs of systemic collapse appearing beneath the seemingly placid surface. Along shallow shelves, anoxic pockets expanded. Invertebrates perished in silent waves, their skeletal remnants settling onto the seafloor. Fish congregated in remaining oxygenated zones, crowding against one another as currents shifted unevenly. Algal blooms, once abundant and reliable, fluctuated dramatically, responding to both nutrient surges and die-offs of other species. Predators hunted more opportunistically, yet their usual strategies failed to match the irregular distribution of prey. The early signs of mass mortality became apparent, a slow crescendo of death whose rhythm was dictated by environmental changes rather than sudden catastrophe. Inland, forests felt the strain of heat, dryness, and shifting soil chemistry. Trees showed irregular growth patterns, herbaceous undergrowth declined unevenly, and the first faint signs of species loss began to appear. Small reptiles and amphibians, sensitive to moisture and temperature, altered ranges, moving toward microhabitats still viable. Insects, integral to nutrient cycling and plant reproduction, reduced activity, further affecting the broader ecosystem. Predators adapted in response, yet the delicate balance between species became increasingly precarious. The terrestrial world, though still teeming with life, now bore the marks of gradual but undeniable stress. The coasts, where land and sea met, illustrated the cumulative effects of these pressures. Shallow tidal flats, pools, and lagoons reflected changing chemistry and temperature, while organisms sought refuge or perished quietly. Crustaceans migrated to deeper waters or shaded crevices, mollusks adhered tenaciously to rocks, and small fish swam in constrained, overcrowded spaces. Algae displayed irregular growth, colouring water with muted greens and browns rather than the vibrant tones of the past. Predatory fish hunted more sporadically, their usual patterns disrupted. Life persisted, but its rhythm was now dictated by instability, and the first waves of mortality began to mark a shift toward mass extinction. Deeper offshore, the ocean's once predictable currents exhibited irregularities in both direction and strength. Temperature anomalies spread further, bringing warmth into layers previously cooled and stable. Oxygen-depleted zones expanded, suffocating invertebrates and stressing fish. Coral-like reefs showed accelerated bleaching, some areas nearly lifeless. Sessile organisms declined, while predators roamed in increasingly desperate search of viable prey. The interconnected web of marine life, which had thrived for millions of years, began to unravel in small but consequential ways, each failure amplifying the next in a cascade of biological strain. On land, the forests became quieter, the air heavier with heat and subtle volcanic particulates. Herbivorous reptiles moved cautiously, foraging in diminished areas of nutrition. Predators adapted hunting strategies, yet competition increased as prey density declined. Insects moderated activity, affecting pollination and decomposition. Amphibians retreated to the last remaining pools, their reproductive cycles disrupted by fluctuating water quality and temperature. Even the most resilient species began to show signs of stress, the subtle beginnings of extinction quietly threading through the landscape. As the sun arced overhead, the ocean shimmered with the reflected amber haze of volcanic ash. Surface waters warmed further, enhancing stratification and promoting expansion of hypoxic zones. Mollusks retreated to crevices, crinoids waved less rhythmically, and fish shifted formations to conserve energy in oxygen-depleted pockets. Plankton populations fluctuated unpredictably, feeding cycles became irregular, and predatory organisms experienced reduced hunting success. The cascade of ecological disturbance, now more visible, marked the transition from subtle imbalance to more overt signs of systemic failure. Evening approached with a heavy, still atmosphere. The forests, plains, and coastal wetlands felt oppressive warmth. The distant sky glimmered with pale, diffused light, filtered through clouds of ash. Amphibians and reptiles moderated activity to preserve hydration. Insects sought microhabitats of cooler air, and birds, yet to evolve in these times, were absent to witness the quiet transformations. In the oceans, hypoxic zones expanded, sessile organisms declined, and the first small die-offs of larger fish were observed. Life endured, but the rhythm of survival had shifted irrevocably. Nightfall brought retained heat across land and sea. Forests and plains remained restless with quiet motion. Amphibians and reptiles moved cautiously, and aquatic life adjusted positions to survive oxygen-depleted pockets. Even in deep waters, thermal and chemical disruptions propagated through the food web, influencing reproduction, growth, and behavior. Across Pangaea, the first true wave of environmental collapse unfolded silently, each organism responding individually yet collectively part of a planetary transformation that would soon reshape all life. The ocean, once vast and rhythmically undisturbed, had begun to acquire a texture of tension, a subtle yet pervasive heat that penetrated even into its deepest shelves. Currents that had circulated nutrients and oxygen with meticulous precision now wavered in irregular patterns, Upper layers, warmed by sun and distant volcanic heat, carried pockets of suffocating oxygen scarcity, while lower layers, heated from below, became hostile zones of toxicity. Mollusks clung desperately to the rocky substrate, their shells faintly powdered by ash settling from the atmosphere above. Crinoids, in shallow reefs, faltered in motion, waving irregularly in currents now heavy with suspended particulate. Small fish, instinctively seeking oxygen-rich zones, formed tighter, more chaotic schools, their movements less coordinated than ever before. Each creature, from plankton to predator, responded with precision to environmental signals they could not name, yet none could fully mitigate the growing lethality of their habitat. Anoxia spread across continental shelves with relentless subtlety. Invertebrate populations that had once carpeted the seabed with abundance began to dwindle, first sporadically, then with increasing regularity. Shells of extinct individuals littered the soft sediments, forming faint mosaics that marked early stages of mass mortality. Fish, unable to find refuge, crowded into remaining oxygenated channels, competing for space in an environment no longer capable of supporting previous abundance. Algal blooms, once predictable in their cycles, fluctuated wildly, alternating between dense concentrations and sudden die-offs. Predators adapted as best they could, moving between microhabitats with opportunistic precision, yet the fundamental balance of the food web began to collapse, thread by thread. In shallow coastal waters, the die-off was more pronounced. Crustaceans retreated into deeper or shaded areas, leaving exposed zones vacant. Mollusks clung with greater tenacity to rocks, feeding less frequently, conserving energy in an environment that had become hostile. Predatory fish, accustomed to steady prey distribution, experienced increasing scarcity, hunting in erratic patterns dictated by oxygen availability rather than instinctual strategy. Algae, struggling under chemical shifts in water, altered food availability further, amplifying the ecological collapse. Even the smallest creatures, from benthic worms to microplankton, felt the cumulative pressure, their life cycles interrupted by subtle yet lethal changes in temperature, oxygen, and nutrient flux. Deeper offshore, the ocean carried the echoes of surface chaos into its depths. Thermal anomalies penetrated previously stable layers, reducing dissolved oxygen and destabilizing nutrient distributions. Sessile organisms, once long-lived and steady, displayed slowed growth, reduced reproduction, and local die-offs. Crinoids, mollusks, and other stationary species faced intermittent suffocation, their survival dependent on the fortuity of remaining aerated currents. Predatory fish and early vertebrates, tracking prey availability, adjusted hunting strategies constantly, yet food scarcity induced stress and mortality across age groups. Each change reverberated upward through the trophic hierarchy, the effects cumulative, irreversible, and devastating in scope. Along tidal flats and coastal lagoons, subtle but inexorable pressures became visible to any observer capable of patience. Pools, once teeming with crustaceans and mollusks, became increasingly barren, oxygen-poor waters suffocating life slowly and silently. Small fish concentrated in remaining habitable zones, struggling to maintain equilibrium in currents warmed by both sun and volcanic influence. Algae fluctuated erratically, sometimes forming dense blooms that masked water clarity, at other times vanishing altogether. Predatory species adapted to these new conditions, yet even their refined instincts could not counterbalance the environmental collapse. The first true wave of mass mortality had arrived, quiet, gradual, yet all-encompassing in its scope. Inland, the forest reflected subtle but profound stress from combined heat, dryness, and atmospheric toxicity. Seed ferns and conifers displayed widespread leaf discoloration, irregular shedding, and areas of complete dieback. Soil chemistry, altered by deposition of volcanic ash and acidic rainfall, reduced plant vigor and altered nutrient cycling. Herbivorous reptiles seeking sufficient sustenance ventured further and lingered less in previously safe zones. Predators adjusted hunting strategies in response, yet declining prey densities amplified competition, stress, and mortality. The interconnectedness of terrestrial ecosystems began to falter, the delicate balance that had persisted for millions of years yielding under sustained environmental pressure. Small amphibians and insects were particularly affected. Amphibians retreated to the few remaining pools, navigating waters now partially oxygen-depleted and chemically altered. Reproductive cycles were disrupted, eggs perished in stagnant or warm waters, and juvenile survival rates plummeted. Insects, sensitive to changes in humidity, temperature and vegetation quality, reduced activity, migrated unpredictably, and in some regions vanished entirely. Pollination and detritus cycles slowed, further compounding stress across the terrestrial ecosystem. Each species' adaptation was individual, yet the collective consequence was systemic, altering energy flow and population dynamics irreversibly. The atmosphere, increasingly laden with particulate matter and sulfur compounds, contributed to widespread physiological stress. Winds carried ash and gases inland, colouring sunlight with a persistent amber hue. The air, heavy and thick, slowed heat dissipation, increasing surface temperatures both on land and in shallow seas. Sulfur-laden rainfall altered soil chemistry subtly but persistently, stressing plant life and indirectly affecting herbivorous and omnivorous reptiles. Even in microhabitats, temperature and chemical changes were perceptible, altering behaviour, growth, and survival. Across continents and oceans alike, life adjusted, reacted, and perished in patterns dictated by environmental extremity rather than biological strategy. Shallow reefs displayed pronounced bleaching and die-offs. Coral-like organisms lost colour entirely in areas most affected by heat and chemical change, while crinoids and mollusks slowed feeding or perished in place. Fish schools became increasingly fragmented, moving with hesitation or abandoning familiar zones entirely. Predators roamed irregularly, searching for sparse prey, yet survival rates declined nonetheless. The ocean floor, once a lattice of vibrant life, began to resemble a subdued and scattered mosaic, reflecting the cumulative mortality that had quietly, inexorably spread from coastal shallows to deeper shelves. Even offshore, the first large-scale vertebrate losses occurred. Early fish and amphibian species experienced mortality from hypoxia, thermal stress, and food scarcity. Juvenile mortality soared, reproductive cycles faltered, and populations declined steadily. Sessile and slow-moving species, incapable of escape, succumbed in place, leaving skeletal remains scattered across the seafloor. The cascading effects of these losses altered predator-prey dynamics, disrupted nutrient cycles, and fundamentally restructured ecological interactions. In every layer, from the ocean surface to the benthic depths, life struggled against conditions increasingly hostile and extreme. Inland wetlands reflected analogous transformations. Pools and streams became intermittent, with water quality degraded by chemical alteration and oxygen depletion. Amphibians, insects, and small reptiles migrated or perished in these shrinking habitats. Plant life, sensitive to soil chemistry and water availability, displayed accelerated dieback, irregular reproduction, and patchy survival. Predators, forced to adapt to erratic prey distributions, experienced heightened mortality. The intricate networks of interaction within these systems, once robust, now faltered under combined stresses, leaving subtle voids and pockets of absence across previously teeming landscapes. Across plains and forests, heat, dryness, and particulate-laden winds combined to create pervasive strain. Large reptiles, constrained by reduced food availability and chemical stresses, moved more cautiously, conserving energy where possible. Herbivory declined in areas where plant vigour faltered, while predators adjusted territory and hunting patterns with increasing difficulty. Insects and small mammals, integral to nutrient and pollination cycles, dwindled in numbers. These incremental losses, individually minor, collectively reshaped energy flow, population distribution, and ecological structure across vast territories. Nightfall brought retention of heat across land and sea. Forests and plains remained restless. Amphibians and reptiles moved cautiously among shaded areas. Tidal flats reflected the muted amber sky. Pools were stagnant and warm, and shallow reefs showed heightened stress. Deep ocean currents carried thermal and chemical irregularities, propagating effects across previously stable layers. The first extensive, visible patterns of extinction had emerged, quiet, gradual, and overwhelming in scope. Life persisted, yet the rhythm of survival had been irrevocably altered, with losses accumulating in every niche, both terrestrial and aquatic. Across the supercontinent, the combined forces of hypothermal waters, anoxic zones, and a toxic atmosphere began to define the new epoch. Mass mortality, subtle at first and now increasingly pronounced, reshaped population distributions, energy flow, and ecosystem structure. Coral-like organisms vanished from shallow reefs, invertebrates disappeared from shelves, vertebrates, small and large, experienced local extinctions, plants and reptiles on land showed widespread decline. The planet, still vibrant in scattered pockets, now bore unmistakable marks of systemic collapse, a world in which survival became a struggle, dictated more by environmental extremity than by evolutionary adaptation. The ocean shimmered faintly under an amber haze as the sun, filtered through layers of volcanic particulate, traced long, muted shadows across the continental shelves. Pools and shallow waters reflected the sky with irregular colour, indicative of chemical and thermal stress. Fish and invertebrates moved cautiously, crustaceans sought shelter, and mollusks clung tightly to rocks. On land, forests and plains retained heat, soil chemistry was altered, and vegetation stressed under the combined weight of drought, acidity, and particulate deposition. Life endured, yet in every movement, every adjustment, every survival strategy, the first great extinction whispered through the world, a slow, inexorable process reshaping existence itself. The ocean had transformed into a realm of extremes, a theatre of relentless heat and suffocating scarcity. Currents, once reliable conveyors of nutrients and life, now moved erratically, carrying pockets of hypothermal water interspersed with zones of lethal hypoxia. Shallow reefs, once vibrant mosaics of colour and movement, had become ghostly landscapes. Coral-like organisms had died in place, their skeletal structures bleaching to ghostly white, forming intricate lattices upon the sea floor that no longer pulsed with life. Crinoids, their delicate arms once waving with rhythmic grace, remained immobile or succumbed entirely, swept into decay by currents now devoid of nourishment. Mollusks clung desperately to rocks, their shells coated with ash and organic detritus, feeding minimally, conserving the last traces of energy in a world that no longer offered abundance. Small fish, instinctively seeking oxygen-rich microzones, swam in tighter formations, moving with hesitation, often abandoning long-familiar hunting grounds. Juvenile mortality soared, the numbers of survivors insufficient to sustain previous populations. Invertebrates, shrimp-like creatures, brachiopods, and the once numerous benthic worms perished across shelves and tidal flats, leaving barren stretches where life had once carpeted the sediments in vibrant abundance. Predatory species, both small and large, roamed in erratic patterns, opportunistically consuming the few survivors, yet mortality among predators rose as well, the collapse propagating upward through the food web. Each disappearance, each pause in rhythm, echoed through the ecosystem, reshaping life with silent inevitability. The coastal lagoons and tidal pools displayed the cumulative effect of these pressures. Crustaceans retreated to the last remaining crevices, often overcrowding the shelters that remained viable. Mollusks adhered to rocky substrates with tenacity born of necessity, feeding irregularly in waters increasingly warm, oxygen-depleted and chemically altered. Algal blooms fluctuated violently, sometimes dense enough to obscure visibility, at other times thinning to near absence, removing critical food sources for primary consumers. Fish congregated where oxygen persisted, sometimes panicking as patches of water became lethally anoxic. Predators, from small carnivorous fish to larger hunting organisms, followed erratically, yet scarcity dictated that hunger outweighed strategy, and mortality climbed inexorably. In deeper offshore waters, the decline was no less dramatic. Thermal anomalies penetrated formerly stable layers, reducing dissolved oxygen and destabilizing nutrient gradients. Sessile organisms, unable to relocate, perished quietly, their skeletal remains accumulating upon the soft, warming sediments. Fish, tracking the diminishing availability of prey, adjusted vertical movements, only to encounter further scarcity as plankton and invertebrate populations collapsed. Crinoids and mollusks, normally reliable components of the benthic ecosystem, declined in density, contributing to a cascading failure across trophic levels. The once vibrant ocean, a realm of abundance, now resembled a shadow of its former self, the pulse of life slowing under relentless environmental pressure. Along continental shelves, hypoxic waters expanded to unprecedented scale. Mollusks perished en masse, their shells forming sparse, scattered patterns across sedimented flats. Crustaceans, retreating into scarce refuges, experienced elevated mortality due to overcrowding and competition. Fish, unable to escape or find adequate food, suffered widespread population decline. Algal blooms, once the rhythm of primary production, fluctuated unpredictably, forming sporadic mats or disappearing entirely. Predatory organisms hunted in desperation, yet the collapse of prey species rendered traditional strategies ineffective. Each extinction, subtle at first, now aggregated into a regional and ultimately continental scale, the prelude to a global crisis. On land, the forests, plains and wetlands showed simultaneous stress. Seed ferns and conifers, long resilient to heat and nutrient variation, displayed widespread dieback. Leaves browned, stems weakened, and sections of forest became silent, lifeless patches. Herbivorous reptiles, constrained by reduced plant availability and the chemical stress of acidic soils, moved less, conserving energy and food. Predators tracked prey more irregularly. Territory boundaries became ill-defined, and mortality increased steadily. Insects, critical to decomposition and nutrient cycling, were increasingly absent, altering the quality of soil and further diminishing plant vitality. The interconnected web of terrestrial life began to collapse visibly, the quiet disappearance of once common species marking a shift toward catastrophic loss. Amphibians, sensitive to both temperature and water quality, suffered acutely. Pools became stagnant, oxygen depleted and chemically hostile. Reproductive cycles were disrupted entirely in many locations. Eggs failed to hatch. Juveniles perished before reaching maturity. Insects, once ubiquitous and integral, diminished in abundance and range. Pollination slowed, detrital cycles faltered, and the forest's regenerative capacity weakened. Small reptiles, dependent upon insect populations and moist microhabitats, experienced food scarcity and physiological stress, resulting in increased mortality. Even species that had survived prior environmental fluctuations now faced conditions beyond their adaptive threshold. The atmosphere, saturated with volcanic particulates and sulfurous compounds, exacerbated the crisis. Winds carried heat, ash, and toxic gases across continents, colouring sunlight in persistent amber tones. The air itself became thick and heavy, slowing heat dissipation and amplifying surface temperatures. Acid-laden precipitation altered soils, stressing vegetation and indirectly affecting herbivorous and omnivorous reptiles. Across forests and plains, humidity fluctuated unpredictably, intensifying the challenge of survival for amphibians, insects, and other moisture-sensitive species. The combined effect of hypothermal waters, anoxia, and atmospheric toxicity created an ecological chokehold, compressing life across multiple dimensions of existence. Tidal flats and nearshore ecosystems, already compromised, became increasingly lifeless. Crustaceans, mollusks, and small fish crowded into shrinking refuges, their movements constrained by both oxygen scarcity and predation. Algae, inconsistent in growth, contributed little to primary productivity. Predators hunted sporadically, often unable to find adequate prey. Subtle interactions that had once balanced the ecosystem vanished, leaving a landscape defined by absence rather than abundance. Life persisted, but its pattern was irregular, fragile, and dictated entirely by the extremity of environmental conditions. Deeper reefs and offshore zones were no refuge. Sessile organisms declined, bleaching and perishing silently. Mollusks and crinoids, essential for benthic structure, diminished rapidly. Fish experienced widespread mortality from combined stressors, hypoxia, thermal anomalies, and food scarcity. Plankton populations, fluctuating unpredictably, destabilized reproductive success for invertebrates and small fish. Predators roamed over increasingly barren seascapes, their survival challenged by scarcity and environmental toxicity. The ocean's once resilient systems had entered an irreversible phase of collapse, with mortality propagating through all levels of the food web. Inland forests became increasingly silent. Herbivorous reptiles moved less, conserving energy in the face of reduced food availability. Predators, facing both scarcity and competition, experienced rising mortality. Insects, declining across multiple functional groups, altered decomposition and nutrient cycles, further stressing plant life. Amphibians and small vertebrates suffered reproductive failures and starvation. Vegetation, weakened by heat, acidity, and insect scarcity, fell into extensive dieback. The terrestrial ecosystem mirrored the ocean's collapse, widespread, insidious, and accelerating with each passing day. The heat, suffused through air and soil, became oppressive. Rivers and streams reflected high temperatures and chemical alteration, limiting freshwater availability for amphibians and reptiles. Shallow ponds evaporated unevenly, leaving concentrated toxic residues that few species could survive. Predatory and herbivorous vertebrates alike adjusted movements, seeking remnant viable habitats, yet such refuges were scarce and temporary. The interplay of oxygen scarcity, chemical toxicity, and heat created a multi-layered stress environment, accelerating mortality across species and reducing opportunities for recovery. By dusk, the amber-hued light fell across barren tidal flats, bleaching reefs, and dying forests. Insects were largely absent, amphibians withdrew to the few remaining pools, and herbivorous reptiles moved cautiously or perished in place. Fish congregated in small oxygenated zones, crowded and stressed. Mollusks clung desperately to rocks, crinoids failed to move, and algae exhibited irregular survival. Predators of every kind roamed erratically, consuming what remained yet suffering attrition themselves. Ecosystems, once dense, productive, and interwoven, now bore the marks of systemic collapse on a scale previously unimaginable. Nightfall brought minimal relief. Heat lingered in soil and water, while the atmosphere remained thick, heavy, and laden with toxic compounds. Forests and plains were silent save for the occasional movement of surviving reptiles or nocturnal invertebrates. Ocean surfaces reflected the amber glow of ash-laden skies. Deep waters carried thermal and oxygen irregularities. Hypoxia persisted across wide areas. Skeletal remains of invertebrates littered shelves, and coral-like structures lay ghostly and motionless. Life, once abundant, was now defined by scarcity, fragility, and the quiet inevitability of extinction. The oceans, once repositories of teeming life, had become a realm of near silence. The heat that penetrated shallow and mid-depth waters now reached previously insulated layers, warming currents that had long maintained equilibrium. Dissolved oxygen plummeted to levels unsustainable for most forms of marine life. Hypoxia expanded relentlessly across shelves, flats, and reef systems. Mollusks perished en masse, their shells scattering over the soft sediment like remnants of forgotten structures. Crinoids, once graceful in their movements, now remained motionless, their feathery arms folding upon themselves in final repose. Coral-like organisms, skeletal and ghostly, bleached completely, forming stark lattices devoid of colour or vitality. Small fish sought refuge in the few remaining oxygenated zones, but competition and scarcity claimed many, and even these refuges were temporary illusions of survival. The tidal flats and coastal lagoons mirrored the ocean's fatal rhythm. Crustaceans crowded into minimal crevices, perished from suffocation, starvation, or predation. Algae, inconsistent and sparse, no longer provided reliable nourishment. Predatory fish roamed erratically, hunting opportunistically, yet suffering attrition as prey became ever scarcer. Juvenile fish, incapable of withstanding hypoxic stress, died before reaching maturity, further accelerating population collapse. Invertebrates, shrimp-like forms, worms, brachiopods, vanished entirely from formerly abundant zones, leaving the substrate barren, an eerie tableau of extinction progressing silently yet irresistibly. Deeper offshore, the collapse extended further. Sessile organisms, incapable of escape, succumbed to oxygen depletion and thermal stress. Mollusks, benthic worms, and crinoids perished systematically, leaving soft sediments littered with skeletal remains. Fish, forced to track scarce prey through erratically warming and chemically altered waters, faced increased mortality. Plankton populations, unstable due to temperature and nutrient flux, failed to support higher trophic levels. Predators, from small carnivorous fish to larger early vertebrates, experienced starvation, diminished reproduction, and declining populations. The interconnected hierarchy of marine life, once resilient, had fragmented entirely, leaving a ghostly, nearly lifeless expanse. On land, the devastation was equally profound. Forests, plains, and wetlands experienced mass dieback. Seed ferns and conifers lost entire swathes of leaves and branches, many trees collapsing entirely. Herbivorous reptiles, deprived of sufficient vegetation and stressed by chemical changes in soil, perished or moved sparingly, seeking the few remaining patches of plant life. Predatory species faced both prey scarcity and environmental toxicity, leading to marked mortality across adults and juveniles. Insects, critical for pollination and decomposition, vanished across most habitats, further disrupting plant regeneration and nutrient cycling. Soil quality deteriorated, leaf litter accumulated unprocessed, and the forest floor fell silent, the hum of life fading to near nothingness. Amphibians, dependent on remaining freshwater pools, suffered catastrophic mortality. Oxygen-depleted, warm and chemically hostile waters permitted only sporadic survival. Reproduction virtually ceased, eggs failed to hatch, juveniles succumbed to environmental stress, and adults died in place. Microhabitats, once offering shelter, became traps. Insects, prey for both amphibians and small reptiles, were absent, amplifying starvation. The few remaining small vertebrates persisted only in scattered, isolated refuges, moving cautiously to minimize exposure to heat, chemical toxicity, and predation. Survival itself had become an extreme endeavor, contingent on the rare confluence of tolerable conditions. The atmosphere, laden with sulfurous gases and volcanic ash, was heavy, acrid, and oppressive. Winds carried heat inland, sweeping across plains, forests, and wetlands with relentless persistence. Sunlight filtered through thick ash, created an amber pallor, softening shadows yet casting an oppressive glow. Surface temperatures rose steadily, soil moisture declined, and air humidity fluctuated unpredictably. Acidic rainfall further altered soil chemistry, affecting both vegetation and animal physiology. Across the continents, the combination of heat, toxicity, and particulate matter stressed every living organism, amplifying mortality and accelerating ecological collapse. In coastal and inland waters alike, subtle gradations of survivability vanished. Pools, streams, and tidal flats, once dynamic ecosystems, became dominated by heat, low oxygen, and chemical imbalances. Mollusks and crustaceans disappeared entirely from accessible zones. Fish congregated in minimal oxygenated microhabitats, crowded and stressed, their movement limited by thermal extremes. Juvenile survival dropped to near zero, reproductive cycles failed, and species interactions fractured. Algae, the foundation of primary production, became sparse and inconsistent, further reducing energy availability across trophic levels. Predation became opportunistic rather than strategic, yet mortality climbed relentlessly, with little opportunity for recovery. Offshore, the oceans were a graveyard of skeletal forms. Coral-like organisms, bleached to ghostly white, formed rigid lattices upon the substrate. Crinoids, mollusks, and sessile invertebrates lay motionless, their tissues decayed or absent. Small fish, predatory and herbivorous alike, experienced severe attrition as food scarcity, hypoxia, and heat combined to overwhelm physiological tolerance. Larger vertebrates, those capable of roaming greater distances, faced the dual threat of diminished prey and oxygen stress. Plankton, the base of the food chain, fluctuated unpredictably, offering insufficient nourishment for even the hardiest consumers. Predation and starvation combined to create cascading die-offs, sweeping through the oceans with silent efficiency. Tidal flats, lagoons, and shallow reefs had become nearly devoid of life. Crustaceans perished en masse, mollusks adhered weakly to substrate, and algae fluctuated in survival without predictable patterns. Predatory fish roamed the barren landscape, hunting what little remained, yet starvation and competition claimed many of these survivors as well. Juvenile cohorts failed to reach maturity, reducing population replenishment, and the skeletal remains of invertebrates, once abundant, now lay scattered sparsely across the sand and sediment. Life, once densely woven across shelves and flats, had fragmented into isolated, struggling remnants. On land, vegetation experienced extreme dieback. Forests, once dense and multi-layered, became open, skeletal landscapes. Seed ferns, conifers, and herbaceous plants disappeared in waves, leaving soil exposed, nutrient cycles disrupted, and microclimates altered. Herbivorous reptiles, now deprived of both cover and food, perished where they could not migrate. Predators, confronted with prey scarcity and environmental stress, experienced dramatic mortality. Insects, nearly absent, ceased pollination and decomposition, compounding soil degradation. Even microfauna dependent on detritus suffered, creating a cascade that further accelerated the decline of terrestrial ecosystems. Amphibians, already stressed, retreated to the rare remaining water sources. These pools were often hot, oxygen depleted and chemically altered, permitting only minimal survival. Reproduction ceased in most locales, eggs and larvae perished, leaving adult populations diminished and fragmented. Insects, prey for amphibians and small reptiles, were largely absent. Small vertebrates survived only by extreme caution, minimizing activity and movement, yet mortality remained high due to environmental conditions and predation. Life in these final refuges existed precariously, governed more by chance than by adaptation. Nightfall brought little relief. Heat retained in soil and water maintained elevated temperatures. The atmosphere remained dense, toxic, and heavy with sulfur compounds. Forests and plains were silent. Oceans reflected the amber haze of ash-laden skies, and pools of fresh water were scarce, warm, and chemically hostile. Hypoxia persisted across shallow and mid-depth waters. Skeletal remains of marine life littered ocean floors, and coral-like structures stood as rigid, lifeless forms. Terrestrial life, similarly constrained, survived only in minimal refuges, the great majority having succumbed to the combined effects of heat, toxicity, and ecological collapse. Across Pangaea, the final stages of this early Permian mass extinction were unfolding. Oceans bore the skeletal traces of once thriving communities. Reefs had vanished, shallow shelves were nearly devoid of life, and both vertebrate and invertebrate populations had collapsed. On land, vegetation had failed catastrophically. Herbivorous and predatory reptiles declined dramatically, and amphibians faced near-complete extinction. Insects and microfauna were nearly absent, disrupting nutrient and reproductive cycles. The atmosphere, thick, hot, and acrid, amplified the stress on all remaining organisms. Across oceans and continents alike, life teetered on the edge of near-complete annihilation, the world now a shadowed echo of its former vibrancy, poised on the threshold of the most profound ecological transformation in its history. The oceans, once a sprawling tapestry of life, now bore the heavy silence of near-complete collapse. Thermal anomalies penetrated even the deepest shelves, and hypoxia dominated vast expanses of water, leaving only pockets of survivability. In these scattered refuges, hardy mollusks clung to rocks with diminishing energy. Crinoids waved weakly, or remained motionless, and the skeletal remnants of coral-like organisms formed ghostly lattices upon the sediment. Small fish, their numbers drastically reduced, swam cautiously, confined to oxygenated microzones that were few and far between. Predators, few in number but driven by necessity, roamed in search of sparse prey, yet the cumulative stress of heat, low oxygen, and chemical toxicity claimed many before they could feed. Each movement was a careful negotiation with a hostile environment, a test of resilience that few could endure. Shallow lagoons and tidal flats had become skeletal frameworks of their former abundance. Crustaceans crowded into minimal refuges perished in silence, leaving the substrate strewn with shells. Algae, inconsistent in distribution, provided limited nourishment, insufficient to sustain even the remaining invertebrate populations. Fish congregated in isolated oxygenated zones, their movements constrained, schooling patterns irregular and weak. Juvenile mortality was absolute in most regions, eliminating the next generation before it could mature. Predators, wandering erratically in response to scarcity, consumed survivors with relentless efficiency, yet their own numbers dwindled under the combined pressures of starvation and environmental stress. Deeper offshore waters echoed the devastation of the shallows. Sessile organisms, immobile and vulnerable, perished, leaving benthic surfaces scattered with skeletal fragments. Mollusks and crinoids, once foundational to benthic ecosystems, were reduced to rare, struggling individuals. Fish populations, already diminished, faced the additional challenge of irregular plankton blooms, limited prey availability, and fluctuating oxygen concentrations. Predators adapted by expanding their range and hunting sporadically, yet attrition remained high. Nutrient cycles, once stable and continuous, had fragmented, leading to localized collapse and further reducing the energy available to sustain life. In coastal regions, tidal flats, estuaries, and shallow shelves were increasingly lifeless. Crustaceans clung to whatever refuges remained, mollusks adhered tenuously to substrates, and algae survived in scattered patches. Predatory fish, forced to hunt across barren expanses, faced starvation even as they consumed the last remaining prey. Juvenile mortality prevented population recovery, and skeletal remains of invertebrates lay sparsely across sand and mud, a silent record of extinction unfolding. Ecosystems, once densely interwoven, had fragmented into isolated, struggling pockets, defined more by absence than presence. On land, the devastation mirrored the oceans. Forests had collapsed in vast sections, with seed ferns and conifers failing to regenerate across exposed soil. Herbivorous reptiles, deprived of sufficient vegetation and constrained by heat and toxic particulate, perished in large numbers. Predators faced reduced prey availability and environmental stress, further accelerating mortality. Insects, vital for decomposition and pollination, were largely absent, compounding nutrient deficits and slowing any potential regrowth of vegetation. Soil moisture was scarce, humidity fluctuated unpredictably, and acidic fallout from volcanic ash further stressed remaining flora. The terrestrial world, like the oceans, had been stripped to its minimal functioning fragments. Amphibians, sensitive to both heat and water quality, clung to the last remaining pools. Oxygen depleted and chemically altered, these waters permitted survival only for the hardiest individuals. Reproduction was almost entirely halted. Eggs and larvae rarely matured, leaving populations fragmented and sparse. Small reptiles survived only in isolated microhabitats, often moving cautiously to avoid heat, desiccation, or predation. Insects, scarce and unevenly distributed, provided limited sustenance. Every action, every movement, every attempt at survival was a negotiation with a hostile environment, and many succumbed despite extraordinary resilience. The atmosphere, thick with sulphurous gases and volcanic particulate, imposed further constraints. Amber-tinged light filtered through dense clouds, casting muted, oppressive shadows across land and sea. Heat remained intense both during day and night, slowing the dissipation of surface temperatures. Winds carried fine ash and chemical residues inland, affecting soil chemistry and plant physiology. Acid-laden precipitation altered water quality and soil nutrients, further stressing organisms attempting to survive in minimal refuges. Across continents, environmental extremity dictated survival, and life persisted only where chance or resilience coincided with tolerable conditions. Tidal flats, estuaries, and lagoons, though increasingly barren, still harboured the occasional survivor. Crustaceans clung to scarce crevices, mollusks fed intermittently, and fish swam cautiously within remaining oxygenated microzones. Algae, patchy and inconsistent, provided insufficient energy to support larger populations. Predators, roaming erratically, consumed survivors, yet mortality among predators remained high as scarcity, heat, and chemical stresses compounded. Ecosystems were no longer networks of interaction but isolated nodes, struggling to function in fragmented form. Each microhabitat was a fragile sanctuary, its continued existence tenuous. Offshore, deeper waters retained minimal populations of hardy species. Sessile organisms, reduced to scattered individuals, clung to the substrate, enduring heat, low oxygen, and chemical stress. Mollusks and crinoids, skeletal yet surviving, exemplified the extreme adaptations required to persist. Fish, few in number, navigated patchy plankton blooms, irregular prey availability, and oxygen gradients with cautious movements. Predators, ranging across increasingly barren areas, hunted sporadically, their survival dependent on both instinct and luck. Nutrient cycles, disrupted and uneven, no longer supported robust ecosystems. Life persisted, but only in fragmented, struggling pockets, a fragile remnant of what had been. Forests, plains, and wetlands on land were similarly reduced. Vegetation clung to isolated patches of soil with tolerable chemistry and moisture. Seed ferns, conifers, and herbaceous plants persisted only sporadically, often stunted and diminished. Herbivorous reptiles, deprived of consistent food sources, moved minimally, seeking microhabitats that offered temporary sustenance. Predators, facing both prey scarcity and environmental stress, experienced high mortality. Insects, nearly absent, disrupted nutrient cycling and plant regeneration. Soil moisture and atmospheric conditions further limited survival, creating a landscape where life persisted in scattered fragments, fragile and tenuous. Amphibians and small vertebrates survived only in isolated refuges. Pools, streams, and shaded wetlands, rare in distribution, offered temporary protection from heat, hypoxia, and chemical toxicity. Reproduction was largely unsuccessful. Eggs and larvae seldom matured. Predation and competition among survivors intensified as resources dwindled. Movement was minimized to conserve energy and avoid lethal environmental exposure. Each day, survival became a careful negotiation with the harsh reality of a world nearing the absolute limits of biological endurance. Nightfall brought slight reprieve from daytime heat, yet temperatures remained elevated and the atmosphere thick and acrid. Forests and plains were quiet, oceans reflected the amber glow of ash-laden skies, and pools of fresh water were scarce and toxic. Hypoxic waters continued to dominate shelves and mid-depth zones. Skeletal remains of invertebrates littered the ocean floor, and coral-like structures stood as ghostly remnants. Terrestrial microhabitats, though providing minimal shelter, were increasingly inhospitable. Life persisted, but only barely, scattered across oceans and continents in a fragile lattice of survival. Across the supercontinent, Pangaea teetered on the edge of ecological collapse. Oceans contained isolated survivors, skeletal reefs, and nearly barren shelves. Coastal lagoons, tidal flats, and estuaries preserved only fragments of their former abundance. On land, vegetation clung to isolated patches. Herbivorous and predatory reptiles were reduced to sparse populations, amphibians survived in few remaining pools, and insects were largely absent. The atmosphere, thick, hot, and acrid with sulfur, constrained all remaining life. Across the planet, survival was now a matter of chance, resilience, and rare refuge. The Permian world had reached the apogee of extinction, teetering on the threshold of total ecological reset, poised for the slow, uncertain processes that would eventually permit renewal. The world that had once been dominated by relentless heat, suffocating waters, and poisoned skies now bore faint traces of recuperation, scattered and fragile. Oceans, though still dominated by hypoxic zones and thermally extreme waters, contained isolated refuges where life persisted. In these rare havens, hardy mollusks clung stubbornly to rocks, and crinoids, sparse and diminished, waved slowly, their feathery arms adapting to minimal currents. Coral-like organisms, skeletal and bleached, survived in isolated patches where conditions allowed slight oxygenation and reduced thermal stress. Small fish, scarce yet tenacious, navigated carefully through these microzones, schooling in cautious patterns that reflected both instinct and necessity. Predatory species, few in number, hunted sporadically, their movements dictated not by abundance but by the rare availability of prey, the balance delicate and precarious. Shallow lagoons and tidal flats, though largely barren, exhibited occasional pockets of life. Crustaceans survived in minimal crevices, mollusks fed intermittently, and algae, patchy and fragile, provided the limited energy necessary to sustain these populations. Fish congregated in oxygenated pockets, their movements precise and deliberate. Juvenile survival, though still reduced, occurred in these rare zones, providing the possibility, however slim, for population persistence. Predators roamed erratically, consuming survivors, yet mortality rates, while still high, reflected a subtle stabilization within these isolated ecosystems. Life existed, fragile and tenuous, yet no longer subject to immediate overwhelming mortality. Deeper offshore waters, previously inhospitable, retained small, resilient populations. Sessile organisms, sparse and reduced, endured in areas where oxygen and temperature conditions remained tolerable. Mollusks and crinoids, skeletal yet alive, demonstrated resilience in the face of persistent stress. Fish, few but adaptive, navigated irregular prey availability, their survival contingent upon cautious movement and selective feeding. Predators, wandering across these marginal habitats, faced continuing challenges of scarcity, yet reproduction, limited and irregular, offered the faintest promise of population persistence. Nutrient cycles remained fragmented, but localized productivity provided minimal energy to support these struggling communities. Coastal environments displayed subtle signs of microhabitat recovery. Tidal flats and shallow estuaries contained small aggregations of crustaceans and mollusks, while algae established patchy, low-density blooms. Fish navigated carefully, schooling in restricted areas where oxygen was sufficient. Juvenile survival, although rare, contributed to slow replenishment of localized populations. Predators, few in number, hunted sporadically, constrained by both scarcity and environmental stresses. Each microhabitat functioned as a fragile island of life, isolated from the surrounding barren expanses, yet vital in maintaining the continuity of existence. On land, forests and plains were dominated by skeletal remnants of vegetation, interspersed with isolated patches of green. Seed ferns, conifers, and hardy herbaceous plants clung to soil pockets with tolerable moisture and chemical composition. Herbivorous reptiles survived in minimal numbers, restricted to zones where food was sufficient and temperatures less extreme. Predators, sparse and cautious, navigated the remaining prey in these refuges. Mortality reduced slightly as ecological stresses, though still intense, allowed for temporary stabilization. Insects, previously scarce, re-emerged in isolated zones, enabling limited pollination and decomposition, slowly restoring elemental cycles vital to plant survival. Amphibians persisted in remaining pools and wetlands, fragile yet resilient. These microhabitats, though limited, offered reduced thermal extremes, oxygenated water, and tolerable chemical balance. Reproductive cycles, while still irregular, produced occasional viable offspring sustaining the continuity of local populations. Small reptiles and other vertebrates survived by restricting movement, seeking shade, and minimizing exposure to environmental stress. Survival was no longer governed solely by chance. Adaptive strategies combined with microhabitat availability allowed intermittent persistence. Life, though still constrained, found footholds amid devastation. The atmosphere, thick and acrid, remained a dominant influence yet began to show faint signs of moderation. Sulphurous particulates persisted and sunlight retained its amber hue, yet slight reductions in aerosol density permitted marginally improved air circulation. Winds continued to carry heat inland, but localized cooling occurred where volcanic activity had waned or where cloud cover reduced thermal influx. Rainfall, still chemically altered, provided moisture sufficient to support isolated plant pockets and amphibian habitats. Across the supercontinent, these subtle atmospheric shifts allowed for the formation of microclimates in which life could endure, providing the scaffolding for gradual recovery. Tidal flats, estuaries, and shallow lagoons, though largely depopulated, exhibited pockets of continuity. Crustaceans, mollusks, and sparse algae persisted in these zones, providing energy for limited trophic interactions. Fish congregated in oxygenated pockets, juveniles survived sporadically, and predators, though few, hunted selectively. Each isolated community was self-contained, yet interconnected with neighboring microhabitats through occasional migration or dispersal events. This fragile network formed the basis for gradual recovery, each node a critical reservoir of genetic and ecological diversity. Deeper reefs and offshore habitats reflected similar trends. Sessile organisms, skeletal and sparse, persisted in small clusters where thermal and chemical conditions permitted minimal survival. Mollusks and crinoids clung to the substrate, feeding intermittently and reproducing at low rates. fish populations navigating scarce prey and oxygenated corridors exhibited cautious behaviors conducive to survival. Predators, few yet adaptable, roamed these marginal zones, balancing scarcity with opportunity. Fragmented nutrient cycles, though disrupted, allowed localized productivity sufficient to sustain minimal ecological function. Life, once decimated, persisted in scattered, fragile refuges across the marine realm. On land, vegetation gradually stabilized in isolated patches. Seed ferns, conifers, and herbaceous plants demonstrated slow regrowth, enabled by occasional rainfall, tolerable soil chemistry, and reduced competition. Herbivorous reptiles confined to these vegetated patches survived by careful foraging and minimized movement. Predators, limited by prey availability, adapted hunting strategies accordingly. Insects re-emerged, facilitating partial restoration of pollination and decomposition, essential processes for ecological recovery. Forests and plains, though skeletal and patchy, began to exhibit early signs of structural reorganization, forming isolated clusters of renewed life amid barren expanses. Amphibians and small vertebrates continued to endure in microhabitats, each individual a testament to resilience. Reproductive success, though rare, ensured continuity of local populations. Movement remained cautious, directed toward resources essential for survival. Predation persisted, but was less lethal in areas where prey populations, though minimal, stabilized sufficiently to sustain limited predator survival. Life, constrained yet persistent, began to reassert itself, exploiting niches left vacant by widespread extinction events. The web of survival, once frayed, slowly rewove itself in pockets of opportunity. Nightfall brought partial relief from daytime heat. Temperatures, though elevated, decreased slightly, enabling minimal activity across both terrestrial and aquatic habitats. Forests and plains remained patchy, yet isolated vegetation absorbed nighttime moisture. Pools and wetlands retained water, facilitating limited amphibian activity. Oceans reflected the muted amber light of an ash-laden sky, and deep waters retained fragmented, oxygenated zones. Life persisted in isolated refuges, survival dictated by microclimate and adaptive behavior rather than abundance. Though the global environment remained harsh, these refuges offered the earlier signs of recovery, fragile yet persistent. Across the supercontinent, Pangaea entered a transitional epoch. Oceans retained sparse, resilient populations, coral-like structures survived in isolated pockets, and crustaceans, mollusks, and small fish endured within oxygenated microzones. Coastal lagoons, tidal flats, and estuaries supported minimal trophic interactions. Terrestrial ecosystems stabilized in isolated vegetated patches, with herbivorous and predatory reptiles, amphibians, and insects persisting sporadically. The atmosphere, still hot and dense with particulates, displayed initial signs of moderation, enabling the formation of microclimates. Across oceans and continents alike, life persisted tenuously, surviving the aftermath of cataclysm and poised on the edge of slow, uncertain renewal. The oceans, having endured the apex of thermal stress and hypoxia, now bore the faint beginnings of ecological resurgence. In the scattered refuges where oxygen persisted and temperatures had slightly moderated, mollusks clung with renewed vigor to rocky substrates, feeding intermittently on the sparse detritus and algae that had survived the catastrophe. Crinoids, few but resilient, waved their feathery arms with slow, deliberate motions, capturing particles carried by the modest currents. Coral-like organisms, skeletal yet still living, survived in small clusters where oxygenation and minimal shading provided protection from lethal heat. Small fish, cautious and sparse, navigated these zones in irregular schooling patterns, hunting opportunistically while avoiding the thermally extreme boundaries of their microhabitats. Predators, few in number but adaptive, moved carefully, consuming available prey while avoiding unnecessary exposure to lethal conditions. Shallow lagoons, tidal flats, and estuarine zones displayed incremental signs of life re-establishing. Crustaceans emerged from the minimal crevices that had sheltered them, mollusks fed more regularly, and algae formed patchy yet persistent blooms. Fish navigated these oxygenated pockets, while juvenile survival, though still limited, allowed for localized population regeneration. Predators, hunting sporadically, found sufficient prey to maintain minimal populations. Each surviving microhabitat acted as a node of recovery, isolated yet interconnected with others through occasional dispersal and migration, forming the fragile foundations of renewed ecological networks. Deeper offshore waters, previously inhospitable, began to harbour modest populations once more. Sessile organisms, skeletal and sparse, persisted in patches of tolerable oxygenation and thermal stability. Mollusks and cranoids fed intermittently, maintaining minimal metabolic activity. Fish, navigating irregular prey distributions, displayed cautious behaviours that minimized energy expenditure while maximizing survival. Predators, few but present, hunted within these constrained zones, balancing scarcity with opportunity. Fragmented nutrient cycles slowly stabilized within these microzones, providing the minimal energy required to sustain localized ecosystems. Coastal and nearshore environments, though far from pre-extinction abundance, displayed a tentative resurgence. Crustaceans occupied crevices, mollusks grazed upon algae, and small fish roamed oxygenated patches. Juvenile survival became more frequent, providing the first signs of population replenishment since the catastrophe. Predators, cautious and few, hunted selectively, allowing both prey and predator populations to stabilize gradually. Each isolated community functioned as a delicate node, contributing incrementally to broader ecological continuity. Life, fragile yet persistent, began to assert itself in the margins of what had once been a desolate marine landscape. On land, vegetation slowly recolonized suitable soil pockets, establishing isolated oases. Seed ferns, conifers, and hardy herbaceous plants persisted where moisture, soil chemistry, and light conditions permitted. Herbivorous reptiles, previously constrained by scarcity, ventured cautiously into these vegetated patches, feeding and moving with precise energy-conserving strategies. Predators, limited in number but adaptive, tracked these prey populations, maintaining minimal functional interactions. Insects, gradually re-emerging, facilitated essential processes such as pollination and decomposition, stabilizing nutrient cycles and supporting plant regrowth. Forests and plains, once skeletal, began to exhibit early stages of structural recovery, with small clusters of greenery offering refuge and resources. Amphibians survived in the remaining freshwater microhabitats, utilizing isolated pools and wetlands where oxygenation and chemical conditions were marginally favorable. Reproduction, previously intermittent, became more regular, allowing for localized increases in juvenile populations. Small reptiles and other vertebrates continued to persist in shaded, cooler areas, their survival contingent upon careful foraging and restricted movement. Predation persisted, yet limited prey abundance and adaptive strategies maintained a delicate balance, enabling species continuity. Microhabitats functioned as ecological refuges, sustaining populations that would gradually expand as conditions improved. The atmosphere, while still laden with residual sulfur and particulates, displayed faint signs of moderation. Winds facilitated dispersal of aerosols, allowing localized reductions in airborne density. Sunlight, though filtered through lingering ash clouds, became sufficient to support limited photosynthetic activity. Rainfall, still chemically altered, provided moisture to isolated patches of vegetation, sustaining both terrestrial flora and freshwater habitats. Across the supercontinent, these subtle atmospheric shifts allowed for the formation of microclimates in which life could persist and slowly expand, offering the foundation for the initial stages of ecological renewal. Tidal flats, estuaries, and shallow lagoons, though limited in distribution, supported tentative trophic interactions. Crustaceans, mollusks, and patchy algae provided sustenance for fish, whose cautious movements facilitated localized feeding. Juvenile fish survival, though still constrained, contributed to population persistence. Predators, few and adaptive, maintained ecological balance within these microhabitats. Each node of life, isolated and fragile, functioned as a foundation for gradual ecological rebuilding, forming the earliest delicate framework of the emerging post-extinction web. Deeper reefs and offshore habitats reflected similar trends of gradual recovery. Sessile organisms survived in small clusters, where environmental conditions permitted minimal activity. Mollusks and crinoids, though skeletal, fed and reproduced at low rates, supporting limited benthic interactions. Fish populations navigating irregular prey availability and tolerable oxygenation displayed cautious, energy-conserving behaviors. Predators, sparse but present, maintained minimal predation, contributing to the stability of these recovering communities. Nutrient cycles, though fragmented, allowed localized productivity sufficient to support the tentative resurgence of life. On land, vegetation patches continued to stabilize and expand incrementally. Seed ferns, conifers, and herbaceous plants established root systems capable of withstanding chemical and thermal stress, creating pockets of sustainable flora. Herbivorous reptiles moved cautiously among these patches, consuming available resources while minimizing exposure to heat and predation. Predators, limited in number, followed prey populations in a delicate balance, ensuring survival for both predator and prey. Insects gradually proliferating restored essential ecological processes such as pollination and decomposition, facilitating further plant establishment and soil recovery. Amphibians and small vertebrates persisted in isolated microhabitats, each individual a testament to survival and resilience. Reproductive success, though limited, sustained local populations and enabled gradual expansion. Movement, foraging, and predation occurred with caution, reflecting both environmental constraints and the adaptive strategies that had enabled survival. Life, once devastated, persisted within these refuges, each microhabitat a fragile nucleus of potential restoration. Nightfall provided relief from daytime heat, allowing minimal activity across both terrestrial and aquatic habitats. Forests and plains, skeletal yet punctuated with vegetation clusters, absorbed nighttime moisture. Pools and wetlands retained water, supporting amphibian and vertebrate activity. Oceans reflected muted amber skies. Deep waters maintained patchy oxygenated zones, and small fish moved cautiously among skeletal reefs. Life persisted in these scattered refuges, with survival increasingly governed by adaptive strategies and microhabitat availability rather than sheer chance. Across Pangaea, oceans contained scattered, resilient populations. Coral-like structures survived in isolated clusters, and crustaceans, mollusks, and fish endured within oxygenated microzones. Coastal lagoons, tidal flats, and estuaries supported minimal trophic interactions, while terrestrial ecosystems displayed early signs of recolonization. Herbivorous and predatory reptiles, amphibians, and insects persisted sporadically in suitable microhabitats. The atmosphere, though still warm and laden with residual particulates, allowed for localized cooling, moisture retention, and microclimate formation. Life persisted, fragile yet determined, poised at the threshold of gradual ecological restoration and the slow renewal of biodiversity. The oceans, long scarred by the extremes of heat and hypoxia, now bore tentative signs of renewed complexity. In scattered refuges, mollusks clung to rocky outcrops with steady persistence, feeding upon the patchy algae that had survived the collapse. Crinoids, skeletal yet mobile, waved slowly, capturing suspended particles and contributing to the fragile circulation of energy within these microhabitats. Coral-like organisms, resilient in isolated clusters, provided limited structural complexity for the remaining marine life. Small fish, cautious and sparse, navigated these zones in irregular schooling formations, exploiting available prey with precision. Predatory species, though few, moved carefully, balancing the scarcity of prey with the necessity of survival, and mortality began to decline slightly as populations stabilized within these microcosms. Shallow lagoons, tidal flats, and estuarine zones began to support incremental trophic interactions. Crustaceans emerged from crevices, mollusks grazed more actively upon algae, and patchy vegetation in the water column created subtle refuges for small fish. Juvenile survival increased in these pockets, offering the first signs of population regeneration and demographic continuity. Predators, though limited in number, hunted sporadically, allowing both prey and predator populations to maintain fragile equilibrium. Each microhabitat functioned as a node of recovery, interconnected with adjacent zones through occasional dispersal, creating the earliest framework for recolonization across previously barren expanses. Deeper offshore waters retained sparse yet increasingly resilient populations. Sessile organisms, skeletal and reduced, persisted in patches where oxygenation and thermal stability were sufficient. Mollusks and crinoids fed intermittently, sustaining minimal benthic interactions. Fish populations navigating irregular prey availability displayed careful, energy-conserving behaviours. Predators, few but adaptive, continued to roam these constrained zones, maintaining functional interactions essential to ecosystem stability. Fragmented nutrient cycles began to recover slightly as localized primary production supported minimal trophic exchange, forming the base of slowly re-establishing marine food webs. Nearshore and coastal environments displayed the subtle signs of micro-ecosystem expansion. Crustaceans occupied crevices and small burrows, mollusks grazed actively, and algae formed low-density blooms capable of sustaining limited herbivory. Small fish moved cautiously through oxygenated patches, and juvenile survival, though still irregular, allowed for incremental population growth. Predators, sparse and adaptive, hunted selectively, ensuring limited ecological balance within these recovering zones. Each node of life, isolated yet interconnected, formed a fragile lattice of resilience, contributing to the gradual expansion of biological networks across formerly devastated marine habitats. On land, vegetation patches stabilized and began slow outward expansion. Seed ferns, conifers, and herbaceous plants rooted within tolerable soil pockets, absorbing residual moisture and resisting chemical stress. Herbivorous reptiles, previously restricted, began to explore adjacent patches, feeding cautiously and conserving energy. Predators, following prey populations, maintained minimal functional dynamics, ensuring survival while limiting overexploitation of scarce resources. Insects, increasingly abundant, restored critical processes such as pollination and decomposition, facilitating soil fertility and enabling plant expansion. Forests and plains, though fragmented, gradually accumulated more extensive vegetation clusters, forming the earliest cohesive terrestrial ecosystems since the catastrophic collapse. Amphibians and small vertebrates persisted in microhabitats, exploiting isolated pools, streams, and shaded areas. Reproductive cycles became more regular in these refuges, producing occasional viable juveniles capable of colonizing nearby zones. Movement was cautious, directed toward available resources while minimizing exposure to heat and predation. Predation persisted, but limited prey availability and adaptive strategies maintained delicate population balances. Microhabitats functioned as nuclei of recovery, supporting incremental recolonization and providing stability for expanding ecological networks. The atmosphere, still influenced by residual particulates and sulfurous compounds, displayed early signs of moderation. Aerosol density decreased in localized areas, allowing sunlight to reach terrestrial and aquatic surfaces with sufficient intensity to support renewed photosynthetic activity. Winds dispersed residual ash, facilitating air circulation and marginal cooling. Rainfall, though still chemically altered in parts, began to deposit moisture that sustained plant patches and freshwater habitats. Across continents, these subtle atmospheric improvements permitted the formation of stable microclimates, creating conditions in which life could expand beyond isolated refuges and slowly re-establish interconnected ecosystems. Tidal flats, estuaries, and shallow lagoons, though still limited, became increasingly hospitable. Crustaceans and mollusks occupied available habitats, algae supported limited herbivory, and small fish navigated oxygenated zones with improved survival. Juvenile fish survival, while still constrained, facilitated slow population growth. Predators, few in number, maintained intermittent hunting, balancing predation pressure with the limited abundance of prey. Each microhabitat functioned as a fragile ecological node, sustaining the earliest stages of expanded food webs and population stability. Deeper reefs and offshore habitats reflected similar trends of tentative recovery. Sessile organisms survived in isolated clusters, mollusks and crinoids fed and reproduced at low rates, and fish populations navigated patchy prey availability. Predators, sparse yet functional, hunted selectively, ensuring minimal ecological balance within these constrained zones. Fragmented nutrient cycles slowly stabilized, allowing localized primary production to support incremental trophic interactions. Life, once near extinct across these zones, persisted and began the slow process of ecosystem reassembly. On land, vegetation patches continued to expand cautiously. Seed ferns, conifers, and hardy herbaceous plants established root systems capable of tolerating chemical and thermal stress, forming oases that provided both shelter and nourishment. Herbivorous reptiles ventured outward from isolated patches, feeding selectively and conserving energy. Predators, limited in number, tracked these prey populations, maintaining functional interactions that stabilized the fragile ecosystems. Insects, now sufficiently abundant, restored essential processes that promoted nutrient cycling and plant regeneration, facilitating gradual ecological expansion. Amphibians and small vertebrates utilized expanding microhabitats to disperse gradually. Reproductive success, though limited, supported the slow recolonization of adjacent zones. Movement was strategic, avoiding heat extremes while seeking nourishment and protection. Predation persisted, yet adaptive strategies balanced survival with ecological equilibrium. Life, increasingly interconnected, began to transform isolated refuges into the early architecture of recovering terrestrial and freshwater ecosystems. Nightfall, though still warm, provided relief across terrestrial and aquatic habitats. Vegetation absorbed nocturnal moisture, enabling minor growth and stabilization. Pools and wetlands retained water, supporting amphibian activity and localized fish movements. Oceans reflected muted amber skies, while deep waters maintained oxygenated zones that allowed minimal trophic activity. Life persisted within these increasingly interconnected refuges, survival no longer dictated solely by chance, but by adaptive behavior and expanding microhabitat networks. Across the supercontinent, oceans, coastal zones, and terrestrial habitats displayed the first signs of coherent ecological expansion. Marine life persisted in isolated refuges. Crustaceans, mollusks, crinoids, and fish formed nascent food webs, and coral-like organisms provided structural support for minimal trophic interactions. Coastal lagoons, tidal flats, and estuaries supported renewed ecological interactions, while terrestrial ecosystems expanded with stabilized vegetation patches. Herbivorous and predatory reptiles, amphibians, and insects dispersed cautiously, utilizing emerging microclimates. The atmosphere, while still warm, allowed improved photosynthesis and moisture retention, facilitating further recovery. Life, fragile yet persistent, had transitioned from post-catastrophic survival toward gradual expansion, laying the groundwork for a renewed era of biodiversity. The world, once reduced to skeletal oceans and barren continents, now bore the tentative hallmarks of renewal. Marine refuges, which had survived the apex of thermal stress and hypoxia, had become more stable. Mollusks clung persistently to rocky outcrops, feeding with cautious regularity on algae and detritus that had endured the cataclysm. Crinoids, skeletal yet resilient, waved their arms deliberately, capturing the faint currents that carried nourishment. Coral-like organisms, skeletal and bleached, clustered in small yet persistent patches, forming the earlier scaffolding for complex benthic life. Small fish navigated these zones with cautious precision, feeding opportunistically while avoiding thermally extreme edges. Predatory species, though still few, hunted selectively, maintaining a delicate ecological balance within the nascent marine communities. Shallow lagoons, tidal flats, and estuarine zones had begun to support consistent trophic interactions. Crustaceans emerged confidently from crevices, mollusks grazed actively, and algae formed more stable blooms that could sustain herbivory over extended periods. Juvenile fish survived with increasing frequency, replenishing local populations and establishing demographic continuity. Predators, cautious yet effective, maintained minimal but functional predation, allowing both prey and predator populations to stabilize. Each microhabitat acted as a node of recovery, connected sporadically with neighboring zones through dispersal events, forming the earliest coherent networks of post-extinction marine life. Deeper offshore waters retained sparse but increasingly resilient populations. Sessile organisms persisted in isolated clusters, feeding intermittently and reproducing at low rates. Mollusks and crinoids maintained minimal benthic interactions, contributing to slow nutrient cycling. Fish populations navigated patchy prey availability with energy-conserving behaviors, while predators, few but adaptive, hunted selectively to avoid overexertion and maximize survival. Fragmented nutrient cycles stabilized incrementally, supporting localized primary production that formed the base for gradually expanding food webs. Life, once decimated, persisted with tenacity, exploiting each viable microhabitat and forming the earliest structures of renewed marine ecosystems. Nearshore and coastal environments exhibited expanding microecosystems. Crustaceans and mollusks occupied available habitats, algae supported limited herbivory, and small fish moved among oxygenated zones with improved survival. Juvenile survival, though still constrained, became sufficient for incremental population growth. Predators, few yet functional, maintained ecological balance while allowing prey populations to recover. Each node of life, isolated but resilient, contributed to the slow reconstruction of marine ecological networks, setting the stage for the eventual return of higher trophic complexity. On land, vegetation patches stabilized and gradually expanded, coalescing into small continuous oases. Seed ferns, conifers, and hardy herbaceous plants established extensive root systems, resisting chemical stress and moderate heat while creating shelter and nourishment for terrestrial animals. Herbivorous reptiles, cautiously exploring newly vegetated areas, fed selectively, conserving energy while gradually expanding their foraging range. Predators followed prey populations, maintaining functional interactions that prevented overexploitation. Insects, now sufficiently abundant, resumed pollination and decomposition at meaningful scales, enabling soil fertility and further plant growth. Forests and plains, once skeletal and fragmented, became recognizable as ecological structures capable of supporting multi-tiered food webs. Amphibians and small vertebrates utilized expanding microhabitats to disperse further. Reproductive cycles became increasingly regular, with viable juveniles capable of establishing new populations. Movement was strategic and cautious, directed towards suitable resources and shelter, while minimizing exposure to heat or predation. Predation persisted within controlled bounds, maintaining balance across emerging populations. These microhabitats, once isolated refuges, began to merge into broader ecological networks, linking aquatic, coastal, and terrestrial ecosystems into a slowly integrated biosphere. The atmosphere, now noticeably less dense with particulates and sulfur compounds, allowed sunlight to reach both terrestrial and aquatic surfaces with increasing clarity. Winds dispersed residual ash, moderating surface temperatures and improving air circulation. Rainfall, while still irregular in some regions, provided consistent moisture in pockets, sufficient to sustain vegetation, freshwater habitats, and amphibian microhabitats. Across the supercontinent, these subtle atmospheric improvements enabled the formation of stable microclimates, fostering conditions in which life could expand beyond isolated refuges into broader ecosystems capable of supporting trophic complexity. Tidal flats, estuaries, and shallow lagoons became increasingly hospitable. Crustaceans and mollusks thrived in protective niches. Algae maintained continuous coverage sufficient for herbivory, and small fish moved more freely among oxygenated zones. Juvenile survival became consistent, ensuring the slow but steady growth of local populations. Predators, few but persistent, hunted selectively, reinforcing ecological balance and contributing to the stabilization of these recovering habitats. Each microhabitat, resilient and interconnected, acted as a foundational unit for the progressive reconstruction of marine ecological communities. Deeper reefs and offshore habitats reflected parallel trends of renewal. Sessile organisms, sparse but persistent, formed clustered structures that supported benthic interactions. Mollusks and crinoids fed and reproduced at low yet sufficient rates, contributing to local nutrient cycling. Fish navigated irregular prey availability, employing adaptive behaviors that optimize survival. Predators, sparse but functional, maintained balance within these constrained zones, allowing both prey and predator populations to establish equilibrium. Slowly, these offshore ecosystems regained minimal functional complexity, forming the earliest recognizable post-catastrophe marine food webs. On land, vegetation clusters continued to expand, merging into small forested tracts and continuous oases. Seed ferns and conifers, rooted firmly in nutrient-recovered soil, created shelter and foraging opportunities for herbivorous reptiles. Herbivores ventured beyond initial refuges, feeding selectively and cautiously, gradually repopulating adjacent landscapes. Predators, adaptive and strategic, followed prey across expanding ranges, maintaining balanced trophic interactions. Insects, abundant and active, restored pollination and decomposition processes, further enabling plant growth and soil stabilization. Ecosystems, once skeletal and fragmented, became structured and resilient, capable of sustaining multi-trophic interactions across expanding terrestrial zones. Amphibians and small vertebrates, flourishing within microhabitats, dispersed further as vegetation expanded. Reproductive success stabilized populations, and movement between connected habitats allowed genetic exchange and ecological integration. Predation continued within balanced limits, ensuring functional ecosystems. Microhabitats merged into broader networks linking freshwater, coastal and terrestrial zones, forming a nascent but resilient biosphere. Life, once reduced to sparse remnants, had begun to reclaim space, demonstrating the persistent capacity for resilience and adaptation. Nightfall, cooler than in the cataclysmic past, allowed extended activity across both aquatic and terrestrial habitats. Vegetation absorbed nocturnal moisture, enabling growth and structural stability. Pools and wetlands retained sufficient water to sustain amphibian activity and localized fish movement. Oceans reflected the muted amber glow of lingering particulates, but provided oxygenated corridors for marine life. Fish moved among skeletal reefs, crinoids and mollusks persisted in scattered clusters, and predators hunted with strategic patience. Life, fragile yet persistent, thrived within interconnected refuges that now formed continuous ecological networks. Across Pangaea, oceans, coastal zones and terrestrial habitats displayed the earliest signs of coherent post-catastrophic ecosystems. Marine communities, once decimated, now supported nascent food webs with mollusks, crustaceans, crinoids, and fish forming functional interactions. Coral-like structures provided minimal habitat complexity, supporting trophic interactions and shelter. Coastal lagoons, tidal flats, and estuaries sustained renewed ecological connectivity. On land, vegetation clusters merged into small forests and oases, supporting herbivorous and predatory reptiles, amphibians, and insects. The atmosphere, warmer yet stabilized, allowed improved photosynthesis and moisture retention, enabling continued ecological growth. Life across oceans and continents had transitioned from fragile persistence to structured recovery. The cataclysmic heat, hypoxia, and toxicity that had once reduced the world to skeletal remnants now receded into history. Marine and terrestrial communities began to interconnect, forming coherent ecological networks capable of supporting functional food webs and stable populations. Isolated microhabitats had merged into continuous ecosystems, allowing species dispersal, reproduction, and adaptive interaction. The planet, scarred by one of its greatest extinction events, now entered the earliest stages of a renewed era where life, resilient and persistent, could once again flourish across the breadth of Pangaea. The oceans, though far from their former abundance, now supported functional trophic interactions. Mollusks, crinoids, crustaceans, and fish formed interconnected food webs, predation balanced by limited but sufficient prey. Coral-like structures, sparse but persistent, provided physical shelter and microhabitats for benthic life. Shallow lagoons and tidal flats supported emergent algae and juvenile populations, sustaining local reproductive cycles. Each node of life, interconnected with others, contributed to a slowly stabilizing marine ecosystem capable of supporting resilience and future expansion. On land, plant communities, once skeletal, now formed continuous clusters of greenery. Herbivorous reptiles foraged cautiously but consistently, while predators tracked prey across expanding territories. Amphibians and small vertebrates utilized microhabitats to disperse and reproduce, stabilizing populations. Insects, abundant and active, facilitated pollination and decomposition, ensuring soil fertility and plant regeneration. Forests, plains, and wetlands began to demonstrate the earliest characteristics of fully functional ecosystems capable of sustaining complex interactions across multiple trophic levels. The atmosphere, now stabilized, allowed moderate temperatures and clear sunlight to reach both terrestrial and aquatic habitats. Rainfall replenished freshwater sources, enabling amphibian reproduction and plant growth. Winds dispersed residual particulates, enhancing air quality and climate stability. Across the supercontinent, these atmospheric improvements reinforced the persistence and expansion of ecosystems, permitting species dispersal and the slow resurgence of biodiversity. Thus, the world, once devastated by boiling oceans and acrid skies, entered a new epoch. Life, tempered by cataclysm, had endured and begun to reclaim both land and sea. Marine and terrestrial ecosystems, initially fragmented and tenuous, now displayed coherence and functional resilience. Species, once reduced to isolated survivors, expanded gradually into the spaces reopened by ecological recovery. The atmosphere, moderate and sustaining, allowed this renewal to proceed steadily. The Permian world, scarred yet resilient, stood poised on the threshold of a new era, a testament to the persistence of life even in the aftermath of near-total annihilation.